Look at that. We are doing a playthrough of the game we made together. Beautiful. What up, guys? Max here, bringing you a brand new game dev YouTube video. And today's video, we're beginning the John Lemon's Haunted Jaunt 3D beginner guide for Unity game development. A little bit about me: I'm a software engineer. I've been working for 2 years already in C# and SQL and JavaScript, HTML, all front end stuff, and a little bit of back end. I'm a full stack developer. I graduated from college literally 2 years ago, and during college, I wanted to make games. And I did take Unity courses. I took some JavaScript game courses, and it's been like 2 years since I actually used Unity because, you know, my job doesn't revolve around making games. It's more of like, you know, industry, advertising stuff. But that being said, I want to get it back into games. I want to make coding tutorials. I want to make game design tutorials, and together I want to eventually make a game. So that's what this channel is going to be about. That being said, I didn't see any YouTube videos on this entire course. So that's what we're gonna do. We're gonna basically do this entire course and probably some of the other Unity courses. So I get familiar with, so we get familiar with how to make a game in Unity, and then we'll continue to make our own game from scratch. That being said, let's get right into it. All right, guys, let's start with part 1. We'll go through all these sections together, and then we'll have our demo game. Perfect. Let's start off with setting up 3D beginner. Let's open that, read this real quick. So this is setting up Unity. All right, cool. So this is just downloading Unity. I'm assuming you guys already downloaded Unity. If not, you just click download link, you download all the stuff. It's pretty simple. I'm gonna skip that part. It's just downloading Unity. So already mark it as complete. Let me do it again. Mark it as complete. Perfect. Now we're creating the project. Perfect. So now you want to go open the Unity Hub. If you don't know what Unity Hub is, I'll show you. It's this thing right here. You could search Unity Hub and boom, you have it. Open it and it'll look like this. Do you want to sign in, make your account? That's just Unity stuff, making your account. And now we want to actually make the project, right? Perfect. Click the 3D project, create a project. Easy. I already marked the step as complete. Okay, so you go to the new 3D, name the project, we'll call it 3D beginner. You can name it whatever you want. The name doesn't really matter, it's just for you. 3D, let's do 3D beginner YouTube tutorial. Boom. Save it to the location that you want. Mine is to my Unity games folder. Pick whatever folder you want, just so it's easy access, and click create. Boom. And just like that, the next step is finished. Now we gotta wait for it to load, and it'll finish loading in a second. And then we want to import the assets next. Okay, we'll do that next. Still loading. Might take a little bit to load, it happens. Boom. Now Unity is loaded, and you see all this stuff. So I'm not sure how familiar you guys are with Unity. Like I said, I used Unity before, but it's been a while. So this is a beginner tutorial, so I'll just act like even myself, everyone is a beginner. So we want to import the assets. Before you install Unity, blah, 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 you want to import the assets. So window, general, asset store. Easy, and it should open the asset window. Let's do that. Go here, see it says window on top, window, general, window. Actually, it used to be in general, but now it's right here. For me, it's right here. If it's not in your general, it's because you probably have a new version of Unity. So you just go to asset store right here. Boom. Click. And now you have the asset store opened up. Assets are a cool place to get like already made scripts, already made art. You could buy it. Some of them are free. You know, it's just your one-stop shop for like things that people already made. So you don't have to like make your own plans. You don't have to make your own trees. You could literally buy every single script to make a game without even coding. Things like that, but you know. So we want to go search for 3D beginner tutorial resources. Easy. Click on the search result, then download, import. All right. So I want to search for this, Control V. There it is. So once you're here, just click on this. Now it takes you to the page of the assets and you click download. Yeah, see, we're making the stealth tutorial. Now it's downloading. It's a pretty decent sized file. It's fine though. Boom. Import. For a complete project will override your current project settings. We just started a new project, so it's fine. Import. For a project will override your... Yes, we just read that. The Unity package has a manager dependencies. Package manager dependencies. Install/upgrade. Huh. I guess install and upgrade? All right. So I was playing around with Unity before, and last time I installed those weird, that update thing. It sort of had bugs in it, so I wonder if they fixed those bugs. We'll see. People were telling me to uninstall it and stuff, but we'll see what happens. So whatever you do, just try to get that, just update everything. It's fine. Let's go. A lot of loading in the beginning. Am I right? All right, import your files. Now we're all set up. Let's explore how the editor works. Okay, so this is more beginner stuff. I guess we'll explain it as it goes. Maybe I could zoom in a little bit. Boom. Okay, so now you get like a second import option. So when you download assets from Unity, you could select what you want. Like, so you could unclick this entire section, but we want everything, obviously, because everything in here is needed. So we just import everything. But if you ever download an asset that you may, I don't want the plants, I only want the trees, and you could like click on what you want. You know what I mean? That being said, import all. Or you can just click import because everything is checked. Oh, that selects it all. Ah, okay. Ah, we already learned something new. Import. Cool, cool, cool. All right, it's still downloading assets. All right, cool. Now that we have all the assets. Cool, cool, cool. There's this little error right here. Import parameters got modified during import. We can just clear that for now. That's the console. If you have experience coding, this is like the console where you can like print to the console. It shows all the bugs, errors when compiling and stuff. But yeah, anyway, let's go back to project. So this is what we have so far. Cool, cool, cool. So now let's go to the next part. Now it basically talks about everything in the editor. Okay. So this is like a really beginner tutorial. So we learn what we're looking at. So the middle is a scene, hierarchy window, project window, inspector window. Now it talks about everything. Okay, so let's quickly go over everything. All right, project window. The project window lists all the files and directories for your project. This is the project window right here. Project window, so it says project. This is the project window. It lists all your folders with all your assets that you're using. 3D models, images, sounds. Basically everything that's an asset goes here. So this is all your stuff. Your code's gonna be here. Your pictures are gonna be here. Animations are gonna be here. All your scenes. Okay, so everything that you're gonna put in the game is gonna be in this. It's like all your stuff. All right, console window. So this is the console window that I was talking about. The console window gives you warnings and errors for your game, and gives you some information for fixing those errors. Like I said, if you're already coded in like other things like Visual Studio, you know, Eclipse, all that stuff, NetBeans. Everything always has a console that tells you everything. Console window is in the tab next to project window. Agree. Yes, true. You can move it by dragging and dropping the console tab. Okay. See, you can move it anywhere you want. So you could click on anything here and you move it wherever you want, as you guys see. But I want to leave it to where it is before, just so there's consistency. All right, the hierarchy window. This is the hierarchy window. This is basically, games are made up of scenes. This is your first scene, sample scene right here. And scene is your level or environment. With every scene, you have a list of objects that you place in the scene. So basically, this shows everything in the actual game, like all the objects in the game. So this is the sample scene. This is the scene, and then inside the sample scene, which is, let's say, a level, there's a main camera and there's a light. So basically, it's just all the objects in the game. And then here's scene view. This is the view. This is, click on scene. Right here, this is game. This is scene view. This is like a live preview. It shows your currently loaded scenes and all. Basically, it shows everything in the scene. We don't have anything in the scene yet, but there's the light and there's a camera. So basically, see everything in the level. And then there's a game window here. And the game window is basically what your camera sees. So right now it's what your main camera sees, but you could always assign a different camera, like, so it'll be your player. So we'll see what your player sees, or we'll see what the 3D camera sees. So this just shows like actually what it'll look like when you're in the game, and so game shows what's in the game, and scene shows what it looks like when you're like designing the level, and the game shows like when you're actually playing the game, if that makes sense. Inspector window. This is the inspector window. This is basically where you do you see all the components of something. So if you click on main camera, we see all the things that make up the main camera, like its position, the actual camera object, the audio, the light. The light has its own stuff. So yeah, it's basically shows everything that an object has, is what the inspector is. Cool. All right, so now that we got through all of that, I hope you guys are following along. Mark it as complete. So now we basically imported all our stuff. We imported all our stuff. We went through how the UI works. And there's one more step. The toolbar and UI navigation. So let's go through all of this stuff. All right. So this is the toolbar up here. This little toolbar all the way up here. The plus, minus, fast forward, all this stuff. So this is the play button. This starts the game. This pauses the game. And this goes through frame by frame. Oh, it's not fast forward. It's frame by frame. This part over here lets you manipulate objects. Hand tool lets you move stuff. You can use this tool to move your scene around. Oh, this moves the scene around. And this is the move tool. Enables you to select items and move them individually. Okay, so this moves like everything, and this moves individual stuff. This rotates stuff. That makes stuff bigger or smaller. Scaling. Rectangle tool. What does that do? Essentially combines. Oh, it combines moving, scaling, and rotation into a single tool. Okay, so this does basically what these three do. These three are combined into this rectangle tool. This is rotate, move, or scale. So this basically does what this does, except 3D version. This is like the 2D version, I guess. And this is the 3D version for 3D objects or 3D game. All right, cool. When you're in the scene, left click to select your game scene. Yep. Left click to select your game object. Oh, left click to select your game object in the scene. So we're left clicking to select the game objects. Cool. Middle click and drag to move the scene's camera using the hand tool. So the hand tool, middle click. Okay. So this is for like editing. So if you want to move, like this is not the game's camera. This is your camera to edit the level, like the scene view. Oh, and then you right click to rotate. Right click is to rotate. Middle click, like your scrolly button, is to move everything. So basically you will zoom in, zoom out with the scroll wheel. So this is basically for like looking at your level from like a designer's point of view. Perfect. All right, so now we know the basic functions of how everything works. Mark as complete. And now layouts. So layouts are just the way you want your Unity to be organized. So let's look at what they got. Window, layouts. There's 4 split, 2x3. So, well here, there's actually no 2x3 anymore. There's 4 split, tall, wide, default. 4 split, tall, wide, default. So let's 4 split. Okay. That looks kind of okay. So this looks like the scene from all angles. Okay, that's pretty cool. Window. Where'd it go? Layouts. Got default. I like the default one the best. Tall. Okay. This one's not bad either. And last one, wide. Okay, I kind of like this one. What are we missing, though? We're missing the hierarchy. Where does it go when we do that? Oh, it goes down here. Oh, okay. This one's pretty nice. But we'll use the default one for now. Because I'm pretty sure it's the one that like, usually everybody uses. Very simple to understand. Cool. And just like that, mark as complete. And we completed all the steps in the introduction. So that was setting up. So we completed the setting up part of the tutorial. Really cool. So yeah, that was part 1. Pretty fast. Now let's actually start into the player character part 1. All right, so now let's begin the actual stuff. The first one was just setting up. Now we're finally in the player character part 1. So this is gonna be also 30 minutes long, but it looks like there's actual stuff that we have to do. So let's get into it. Let's follow along. All right, it says save the scene. In previous tutorial, you're expected to blah blah. Next up, add objects to your scene. When a new project is created, it automatically creates an empty scene called Untitled. Yes, we see that. We see that. Untitled. Well, it's called sample scene. Same thing. So go to file, save. You want to so file save or control save. When you want to save. All right. There's already a folder called scene. So let's save the scene as folder as main scene. All right, cool. Oops. All right, so let's do Control S. File, save as, scenes. Let's rename it to Main scene. Boom. Easy. We're already making a game. Okay, you'll see this in scene and asset called. So if we go to scenes, main scene, perfect right there. I guess we don't need this scene anymore. Sample scene, delete. Boom, main scene right here. All right. Next step. Did it. Yeah, keep spamming Control S while you're working so you don't lose any of your stuff, just in case a crash happens or something. All right, add a character model. Previous version of the previous tutorial, you import all the assets that you'll need. Yes, we did. The first asset we'll be using a 3D model. Most of the things you see in 3D games are models, including characters, environment. These are usually created outside of Unity and are then imported and given functions to functionality. To use these models, you need to add them as game objects, creating instances. Let's add John Lemon. In the project window, go to Assets, Models, Characters folder, and find the model called John Lemon. Drag the model from the project view window into project scene, into the scene view. This enables you to choose exactly where you want to place the object. Yes. When your cursor over... Okay. Drag the model from the project window into the scene. All right, so let's do that. So we go to Models, Characters, John Lemon. You click him. Now drag him. Boom. Nice. Nice suit. With your cursor over the scene view, press F to focus. So this focus F. Okay, so F focuses on the thing you just added in, if it's highlighted. So I clicked on this. So if I click on this, F. F. If I click on this, F. If I click on John Lemon, F. Okay, there you go. Click Control Save now. Boom. Oh, look at John Lemon. Next. Okay. Show the character in the scene. Good, good, good. Now he has two components. Animator and Transform. This shows the size and location. Animator shows what can be animated. But there are more to the character than just those features. For example, you can see the player's character in scene view, but neither of these components are accounted for. What's not accounted for? There's more to this character than just features. For example, you can see the player character in the scene view, but none of these are accounted for. But there's more to this character than just those features. Well, yeah. For example, you can see the player character in the scene view. Oh, okay. Okay, so they're saying basically that these are just for his position, his animations, but like there's more to make him like that you could actually see him, but that stuff is just like engine stuff that we don't care about. Oh yeah, whatever. All right, so now we have to go to the hierarchy window. We can see all of John Lemon's stuff, what he's made out of. The game object has two children, another game object called John Lemon and one called Root. Select the child game object called John Lemon. Yeah, see, he has Root. So Root looks like his bones. Yeah, what he's made out of. Doesn't really highlight anything. I feel like it's his bones. And now so John Lemon is the actual 3D model, and I'm pretty sure the Root is his bones. If I'm not mistaken. Yeah, the spine. I'm pretty sure that's what where you get all the animations from. I'm assuming. I guess I'll talk about it later. But anyway, so here. Click on John Lemon. Yeah. We see all his stuff. Skin mesh renderer, his shaders. Some more of his stuff. This game object has a component called skin mesh renderer. This is what enables you to see the character. Cool. Models are made up of mesh triangles and renderers. A skin mesh renderer is a special type of mesh renderer that allows you to mesh to change shape based on the positions and rotations of all the model's bones. These bones are child game objects of the model. John Lemon's bones are all children of the Root. Yeah, see, I was right. So these are all his bones for like animating in the Root, and John Lemon's the actual character. So when you're making a 3D character in like any program, you have the actual character, and then you have inside the character are his bones, which is how you animate, and then you get like linked in the animating software. All right, cool. Yep, we see all his stuff. Each of these game objects is part of the click the play button to enter play mode. And left on you call it is transform component, find the rotation. Okay, so click the play button to enter play mode. Play. Okay. So this is what you should see ish. In the hierarchy mode, select the game object called left forearm. In its transform component, find the rotation field and set the Y value to 90. In a scene view, you should see that John Lemon's left arm has bent 90 degrees. This is essentially how you'll animate John Lemon. The animator component on the character's parent object will change the rotation of all the bone components. Okay. Exit play mode by pressing the play button again. Notice that any changes made while you're in play mode are not saved. Alright, so if you make any changes to things while the game is playing, then nothing saves. So they said they want me to go change his what? His left forearm. Left arm, left forearm, rotation Y 90. Oh, I changed my scene by accident. 90. Alright, so we set it to 90. We can't really see. We can see it here. See, like, the game is what the camera sees. We haven't really changed the camera yet. But the scene is, like, what the scene looks like. And look, we changed this to 90. So that's pretty cool. So we gotta, like, play around with it now. Ah! Oh, yeah. Oh, my God. Alright, we don't want to touch that. Z. Oh, I just snapped my elbow. Anyway. So yeah, that's how you're gonna eventually animate stuff. Exit play mode. We did that. Collapse all the game objects by holding Alt and click on the arrow next to John Lemon. So that's a shortcut key. So if we click Alt on John Lemon, that didn't work. What does it say? Collapse all the game objects again by holding Alt Windows or Option and clicking on the arrow. Oh, the arrow. There you go. Perfect. Can I just click on it? Oh, wait. Well, if I do this, click on it. Okay, it stays. So if I just do that, Alt. Okay, cool. So Alt hides, collapses everything. But if you just click on the arrow, it stays expanded unless you click them individually. All right, mark as completed. Cool. What are prefabs? Prefabs are special type of assets that represent a game object or collection of game objects with components that are already set up. Okay, they're like blueprints. Each instance of a prefab is linked to the prefab asset, so changing the asset will change all the versions of prefab in all scenes. The first use of a system in your project will be to make the character a prefab. This means that if you go on to make multiple levels for the game, you won't need to remake John Lemon for every level. So basically, we're making a variable John Lemon, except the variable is an object in your assets. Okay. John Lemon game object has a blue name and a blue cube icon, but there's a small white piece of paper over the cube. Small white piece of paper over the cube. Oh, okay, that small white piece of paper. It's sometimes close. Unity models work like read-only prefabs. They're blueprints for creating a system model, but the blueprint itself cannot be changed. All right, so that means you can change this, but it's like a fake prefab. So we want to turn John Lemon into a prefab. So now we're gonna do that. Turn the character into prefab. Drag the game object from the hierarchy into assets prefabs folder in project window. Okay. So now we want to take John Lemon. We want to go to that. So this is for organizations. Go to the prefabs folder. Take John Lemon. Boom. Now, which one do we click? Original prefab. What's the difference? All right. Boom. Now Jaunt Lemon is a prefab. And look, see, now it changed. Now it's no longer a temporary prefab. It's like, I mean, a read-only prefab. Now it's actually a prefab that you could edit. And it'll get affected if I change this. It'll automatically change all instances of Jaunt Lemon. Now Jaunt Lemon is a prefab. Any changes you make will change him. Let's save. Okay, make sure you save. Now, blah, 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 blah. Now you can open Jaunt Lemon prefab. In the inspector window, click on the prefab. Okay. So click Control S for save. Open prefab. Ooh. Interesting. What happened here? So like open the prefab in like some old. Oh, so this is only the prefab now in our view. Interesting. Unity prefab has now. Okay, so we're in prefab mode. This mode takes you out of the scene that you were editing and puts you in a temporary scene with just a prefab. The scene view has changed slightly at the top. There's a new bar which says Scenes Jaunt Lemon on the left and has a check label autosave on the right. Jaunt Lemon is the breadcrumb of the prefab currently being edited in prefab. In this case, you are only editing the Jaunt Lemon prefab, and going back from here would take you back to the scene you're editing. Okay. Disable the autosave checkbox. Enabling this will slow you down. A save button will appear so you can manually save any changes you make to the prefab. Yeah, you don't want autosave because you make a mistake, then kind of things go poopy, and that's it. All right, so where's that disabling button? Autosave right here. Boom. Cool, cool, cool. On the left, there's an arrow that'll take you back to. That will take you back along the breadcrumb. If you click the arrow now, it'll take you back to the main scene. Okay, so it's like your history. The other 3D project, you'll be editing prefabs. The most of the time, you'll be entering prefab mode, getting used to switching between editing the scene and editing a prefab. Now that you're ready for your first changes, to make your first changes to the Jaunt Lemon prefab, ooh, by animating it. All right, cool. So basically, we could do this. You could go, where was it? Click on the breadcrumb. So where's the back? Do I not see it? Oh, right there. Hierarchy. Oh, right here. Boom. And then that takes you back to the main scene where you're actually going to edit the game. But we're going to go edit Jaunt Lemon. Like this. Boom. Easy. All right. So we're doing this tutorial like I'm a newbie. I am a newbie. I may be a software engineer, but I'm a Unity newbie, even though I used it before. But hey, we're learning together. That's why you're watching this video. You get to learn with somebody. It's the best. All right. Mark is complete. Animating your character. Ooh. Your player character is going to have two different animations in this game. A walk animation for the player moves and an idle animation for them not moving. Okay, simple. Select the Jaunt Lemon game object and take a look at the animator component in the inspector. The first property is called controller. This takes a reference to the type of assets called animator controller. Okay. Which we're going to use to get Jaunt Lemon moving. Animator controllers contain a state machine, which determines what animation the animator component should be setting. Okay. It's right here. So he has no controller right now, so I guess we have to set it. See, he has a controller. It needs an animation controller, but there is none. So I guess we're going to add that. Okay. Yeah, there you go. Let's make the animation controller. Assets animation. So we have to go to the animation folder. All right, this is just all organization. Okay. So what we want to do is go to the animation folder. And how deep do they want us to go in it? Animation, animators. Okay. So here we're going to right click. You could also right click to find stuff. Animation controller. Or you could just go to the long way. Instead of right clicking, you just go assets and create animated controller. Game object. Assets, create animator controller, but we can just right click here, create animator controller. And we're gonna name it Jaunt Lemon. Boom. And then we're gonna double click it. And now we're in the animator tab. See? Animator tab. The animator window has two main sections, a panel for editing animator layers and animator parameters. An area which displays the state machine itself on the right. So this is the state machine. These are the parameters and layers. So what are the layers? I guess editing animator layers and animator parameters. Doesn't really say, but alright. Click on the parameters on the top left. Okay, click on the parameters. Boom. The animator controller state machine makes decisions based on the current value of the animator parameters. Okay. These are set by a script. You will need one parameter for every independent variable which can affect the animation. Okay. So now I'm going to have two animations, idle and a walking. So there are two states it could be in walking or not walking. So we're probably going to want booleans, true or false, right? Yep. There's a float, which is a value. There's an int, well, a decimal value. There's int, which is no decimal, true or false. A trigger is a parameter that is a special type of parameter which doesn't hold a value. This causes a change from one animation to another. Okay. So we're going to go make a boolean variable. A true or false variable. So click plus, make a bool. Is walking. All right, cool. So we're going to add a bool. Call it is walking. Woo! This is the default value parameter. Without a player input, your character is going to be stationary. So is walking should be false. This means you don't need to change anything here. All right, but if you check this, that means it's true. If you uncheck this, that means it's false. All right, easy. Mark as complete. Setting up animations. Now that you have a way of determining which animation to play, but there are no animations ready yet. True. Assets, animation. Currently, animations have icons showing what they look like. However, in this case, it'll be easier if you go to assets in a list view. In list view, okay. However, find the slider at the bottom right of the project and drag it all the way to the left. Okay. So you go to animation, drag it all the way to the left. Ah, okay. So if you go to the right, it shows you the actual image. This little scrolly thing on the bottom right. But if you scroll to the left, it shows you the actual name stuff. Okay. So if you actually want to see what you're looking at, you got to go to the right. If you want to see the names, go to the left. Okay. You see 5 models, 2 of which start with John. The naming convention lets you know what. Okay, this is naming convention of the variables. So expand John Idle and John Walk. You can see their sub assets. These sub assets show immediate children. Okay. In order to use those animations in your animator controller, drag them from the project window to the animator window. Start with idle. Okay. So what we want to do now is, see, we have this animator window here. We want to get John Idle and John Walk. So if you're wondering how to get these animations, basically you make the animations for game objects either in Unity. For example, there's like assets that do it for you. You could get assets that already have animations from the asset store or somewhere online. There are easy things to do, like if you have a door, you want to open a door, you could animate it to rotate. But if you want to do like crazy stuff like walking and like jumping, usually the other software like Blender or like some 3D modeling software. All right, so now we have the animation. So this is okay. An animator state is part of the state machine that has the animator controller. Can I read English? The animator state is part of the state machine that an animator controller contains. The state machine contains logic that determines the current state. The default state is displayed in orange. So this is the default state. So idle is the default state because it's orange. The default state can be changed by right-clicking on the state and selecting set as layer default state. Aha. Okay. Cool. Your state machine now has 2 states, but no logic. Yes. Currently, the same machine will start in the default state and never change, so download will always be idle. In order to add some logic, you need to make animator transitions. Okay, cool. And animator transitions. So right click on idle, make a transition. Okay. So now we want to do right click, make transition. Boom. And we have to do it the other way too. So you go from idle to walking and walking to idle. Boom. Easy. Now that has a way of transitioning, but we have to make the variable. Okay. Select the transition from idle to walk by clicking on the connecting line. Then look at the settings from the transition. The first thing you need to change is has exit time checkbox. If has exit time is true, then after a certain amount of time that has passed, the transition will automatically be taken, and the state machine will play the next state. In this game, it's important to control when the transition is taken, so disable the has exit time checkbox. Interesting. Okay, so click on this. So we want to remove this because that will automatically do the transition over a certain amount of time. But we want to control when that's going to happen, so we don't want it to be automatic, which is interesting. The transition needs at least one condition or an exit time to be valid. Otherwise it'll be ignored. Oh yeah, so it's basically saying that if basically saying that you need like a variable. All right. Further down the spectrum, you'll be warning saying the transition. You say, yeah, there you go. Because you just disabled has exit time box, there's currently no reason to ever take this transition. Okay, so it's basically giving you a warning saying that you have no way to transition. All right, cool. Mark as complete. Add conditions to your transition. Okay. Is walking true? All right, so conditions here. Add is walking true. Perfect. Select walk to idle, disable, the same thing. Okay, so I do the same thing except with the other animation. This one. Boom. Boom. False. Easy. Mark as complete. Alright, we're halfway through. Halfway through. Assign the animator controller to the Jaunt Lemon prefab. Alright, so this is pretty simple now. Now see we're getting quick with it. So now what we want to do, so we have this. This is our, let's go back to big view. So now we're going to go back to prefabs, Jaunt Lemon, and now we wanted the controller, so we want to search for it. Jaunt Lemon, which is the one we just made. Or you could go to the folder and drag it into this slot, but we could find it right here. Double click. Boom. Mark as complete. Really good. Make your character react to physics. Okay. Your character is going to be navigating around a haunted house with different rooms and corridors to explore, and he's not a ghost. It's important to make sure he can walk through walls. Okay. So now we're done with the animation stuff for now. We still have to like assign how those variables work. We just got the base, but now we're doing the physics of the character. In order to do this, you're going to have to make Jaunt Lemon prefab react to physics. Open Jaunt Lemon's prefab editing mode. In the inspector, you'll find two components: transform animator. In order to react to physics, your character needs two more components: a rigid body and a collider. Okay, rigid body. Okay. Okay, so first we're adding a rigid body. All right, so what you want to do is go to your prefab, open prefab editing. Add components. If they said rigid body, but we're doing rigid, not 2D. It's not a 2D game. Regular rigid body. Boom. Really good. Save your work. Okay. Now that you are given Jaunt Lemon prefab rigid body component, it'll react to physics such as gravity. Let's play Enter. You'll see that. Let's play blah blah blah. Okay. So basically, okay, so we add that, so he says click play. Oh, he's playing the animation now. So he's far away from our camera. Let's get him closer to our camera. Nothing happened, actually. Okay, so it says return to the main scene. Click play. Character follows short distance and stops. Press the play button again to exit play mode. This is because of the animator, the third property on the animator. Components apply root motion, which is currently enabled. What is root motion? Animators animations are used to move and rotate all game objects. Blah blah blah. The game object called root in the Jaunt Lemon's prefab hierarchy refers to the root of the skeleton. This is not the actual root game object. The root game object is whichever game object the animator's component is on. So Jaunt Lemon, apply root motion. Apply root motion is enabled on your animator component so that any movement on the root and blah, 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 blah. Since the animator is playing in idle, there's no movement, so the animator will always apply no movement. So I just Jaunt Lemon move at all. Okay. Apply root motion is enabled on your animator component. Apply root motion is enabled on your animator component, so any movement of the root and animation will be applied to every frame. Do I have to do anything here? It's currently enabled. Apply root motion is enabled on your animator components. Oh, apply root motion is enabled on your animator components, so any movement from... Okay, I'll just explain what it does. Since the animator in playing idle, there's no movement, so the animator will apply no movement. So why does our Lemon game option move at all? This is due to update mode of the animator. What is update loop? Game works in a similar way. It's just an update loop, which happens every like. This is just describing what an update loop is. Each time a frame is displayed, a number of things happen in order. All you need to know now is the custom components update methods that happen. Okay. So basically, the update loop is just like what's updating every like second or whatever in the game, and a fixed update. So, but you can't change how often this happens. But a fixed update loop, you can. Okay. Alright, first let's get back to editing. In the inspector window, click the prefab open button. Okay. Okay, so now we're actually fixing it. So that was just explaining stuff that probably we don't care about. Because now this is where we're getting to. Inspector window open. Okay, so now we have to go back. But first thing I want to do is I want to move him closer to the camera. Save. Remember to save. Alright, camera is at 0, 0, 0. So what if I just put him at 0, 0, 0? Did I forget to do this? Alright. Now let me move him even further back. Alright. So now I can actually see him. Alright, perfect. Control S. Go back to the prefab editing. Alright, so I click on John Lemon. Go to animator component. Select animate physics. Go to animator component in the update mode property dropdown. Animate physics. Oh. Anime physics. Update mode. Okay, I didn't see that. Go to animate component in the update mode property dropdown and select animate physics. This change will cause the animator to move the character in time with physics. Now there should be no competition between update loops to move the character. Alright, so there's physics in your game. You always want to animate physics. Okay. Or at least time. You already seen that animations don't have any vertical root motion, but this one stopped your limit from moving vertically after colliding with something. You've already seen that the animations don't have any vertical root motion, but this won't stop John Lemon from moving vertically after colliding with something. There are a couple of ways that this can be stopped. Most obvious is disable use gravity on original object. This will stop character from falling, but this isn't exactly what you need yet because we want gravity. Constraints. These constraints are properties restrict the directions in which a character can move. Okay. X, Y, Z. X is red, Y is green, Z is blue. Okay. So we don't want to do anything here? Okay. Game objects without parents in the scene all have positions relative to the scene 0, 0, 0. Game objects with parents all have relatives to their parent. However, since game objects can be rotated, a child's relative or local position will be their parents' rotated coordinates. It is these local coordinates that original restraints refer to. Let's have a look at the local axis of John Lemon. Select John Lemon. You'll see X, Y, and Z. So what constraints should your character have? Your character needs to be able to move forward and from side to side. So there's no need to constrain X or Z. However, it's important that it doesn't move up or down. To stop that, enable freeze position Y. Rotation refers to the rotation around a specific axis. For example, if the character was rotated around its x-axis, it would look like this. Z side to side. Well, yeah. John Lemon should move either of these ways. Interesting. Okay. So we don't want him to be able to move up and down, and we don't want him to, and we only want him to go rotate sideways, like you're turning like that. So we stop X and Z. Cool. Add a collider to John Lemon. A collider is what you use for collision detection. So either if you collide with an object or run into a wall, all that stuff. Click Add Component, Capsule Collider. So we have to change the size of the Capsule Collider. Okay. So you want to add components. Capsule Collider, not 2D, 3D. I'm covering it a little bit, but I'm only covering the direction variable. Alright, so see, it's at the bottom. It doesn't really cover our character at all, really. So we're going to change that. Because you want it to cover your entire body. That's like you, your body, you know? See? I can't go through me. Change the collider's height to 1.4 and center property 0.70. Zero, 0.70. So 1.4. 0.7. I have hotkeys on my numpad. I gotta turn those off for my scenes. But yeah, boom. 0.7 looks like that. So 0.70. Radius, they have 0.4 actually. And 1.4 for the height. Yep. Alright, that looks like it covers him. Yeah, that looks pretty good. Perfect. It's a little wide though. It's pretty good. Okay, I made it to 0.4 now. Okay. Perfect, that's what we have. Boom. Oh, I forgot to mark off this step. Which step did I didn't mark off? Oh. Perfect. We added the collider. Mark as complete. Summary. Now the tutorial started working on the character. I scratched over his power of prefabs. Mark as completed. Boom. We finished character part 1. Let's go. Good job, guys. Alright, let's get to the next part. Alright, so now we're on player character part 2. This one says an hour. The last one was says in half an hour. It took us like a little bit longer, I think. Or a lot longer. This one says an hour. So this is where we're actually writing some code. So this is going to be pretty cool. It's probably going to be like an... Because I'm learning it as I go. You're learning it with me as we go. Probably going to take a little bit longer than an hour. But that's cool. Let's do it. What is a script? Okay, we can skip this part. A script is just, you know, code. A script is creating like an asset as a prefab. Adding a script to a game object as a component is actually instantiating that script. Just as adding a prefab to a scene and instantiating the prefab. Alright, so you instantiate the script by just dragging it onto a prefab. We're using C#. I use C# at my job. Using means it's like a keyword using something from somewhere else. Public means that anything can access it. It's just different coding terms. So basically, if you're somebody who has no coding experience, so basically when I started learning game design, like when I just started college, I was in like intro to computer science. I don't know a lot about coding at all. I tried to make a game following like YouTube tutorials, and it took me so long to fix the tiniest bugs and like why is this not working? It's because I didn't understand simple like coding logic. So if you have no coding experience, I'll try to help you and this will try to help you as well. But if you do have coding experience, the coding part should be pretty easy to understand. The hardest part about this is just like knowing where everything works with like Unity and like how to connect everything. But the actual coding should be straightforward because once you learn one type of language, you can learn all of them. All scripts you'll be writing in projects take the form of mono behaviors. Mono behaviors are special types of scripts that can be attached to game objects. Okay. Complete. Create your first script. Let's go. Player movement. Aha. Hoo. What's mono behavior? Okay, so those are components. Okay. Find assets, create script, C# script named player movement. Let's copy this so I don't have to write it. Now some scripts are going to be used as a component. Some scripts that are going to use as a component need to have the same name on the asset as the class name. Alright, so player movement is the name of the script, so it has to be the name of the class. Same thing in like any language, really. All right, so if you rename the asset, you're gonna also have to rename the class manually. All right. All right, cool. We're gonna go to assets, scripts, create, C# script, Control V to place player movement, and now we will open it. You could double click to open it. For me, it's probably gonna load. Visual Studio. I like Visual Studio as my IDE. That's what I use for work. But I think that Unity has its own one built in. Unless it's that I know a long time ago they had like their own one. But you can use pretty much anything. Visual Studio is free. Visual Studio Community, it's free. So it's a really good one too. It's professional. Microsoft Visual Studio. All right, so this is the code we have. Using Unity Engine, this is just importing stuff. Player movement's the name of the script. Mono behavior remains the component. This is the start. This is where basically when the object is created with this script, this runs automatically in the first frame, and the update is the loop that happens throughout the entire game. All right. Now I gotta rotate between 3 different tabs. All right. This is what you see. Find the line which starts public class, pub player. Okay, that's the class. This one defines the class name. If your script doesn't say player movement, delete the script asset and make a new one called player movement. Okay, we did that. Now that you've created your script, you can either double click the asset or click open. Scripting editing is not done inside Unity. Instead, it opens on a program called Visual Studio. Oh, okay, so actually use the Visual Studio now. Before it used like they had their own thing called Mono Develop. I guess I just switched to Visual Studio now. Okay, cool. So let's like break down the script. So this is like for understanding how coding works in Unity. First 3 lines are basically imports. Using directives, these are implemented elsewhere. They allow you to use code implemented somewhere else. So you could use you can use another script file. You can use other built-in engine stuff. Basically, using is to use things that are outside of your actual script file. For example, the word mono behavior in the next line would not be able to be used if you don't have using. Yeah, see, mono behavior doesn't exist unless you have importing. So this just imports everything. Yeah, that's basically pretty much it. Class declaration. This is just basically coding stuff. Can't really go into describing how code works. You should have a little bit of experience with how coding works. Classes are like plants, for instances, which are called objects. When a class is instantiated, the instance is called an object. Objects are building blocks of code. Yeah, this is just basic stuff. All right, we're gonna skip fast forward this part. I'm just gonna assume that you know a little bit about coding. This is basically a function. You know what I mean? Void means it doesn't return anything. You know what I mean? It's just simple stuff. Public means it's available to everything. You know? Alright. These are comments. You could comment code with 2 side slashes. Forward slashes. Alright, now let's describe what start means. Okay, this is the return type. Okay, it's actually teaching you how to code. This is the return type. Void means it returns nothing. Yeah, nothing. It could be like Boolean. It could return true or false. It could be int start. You could return a number. You know, that's just the type that it's returning. But because this is like the starting thing when the script starts, it's not going to do anything. It returns nothing. The name of the method. Yeah, function method. In this case, it's called start. After the name of the pair, this is where like parameters go. In these parentheses, we would take a chance to declare what type of data they want to take in, like parameters. This is just describing how to code. Okay, so basically saying that start is one of the methods in Unity that are made by Unity. So they already have a special use case. So you can't make your own you can't make your own void start because there's one already exists. I think that's what it's saying. I must say it's a special method. It's called as soon as the game object is on start, which usually as soon as the scene starts. This makes it ideal for doing things to set up, so you don't want to repeat things. All right. Yeah, so basically start is a one-time run. One-time run. Where you want to like declare all, like start all your variables. Anything that you want to only declare one time. Because if you were to like say declare a variable in start, let's say x equals to true, right? It only happens once. But if you did that in the update part, it will be setting x equals true every basically frame, which is very bad for performance and is bad. It'll make things start lagging eventually, depending how many times you do that. All right, pretty simple stuff. All right, just describing basically how code works. Create variables. Okay, now we're actually going to create variables. So we're probably going to do this. Okay. Your character script needs to take in user input and translate it into the character movement. The first thing you're going to need to do is get some data from Unity's input system. The script needs to check what's happening in input at all times. Since update is called every frame, it makes perfect sense to check the input there. But specifically, what does one want to check? It makes sense to move the character using the arrow keys or WASD. So the script needs to check the values of those specific keys. Okay. So we're going to make a script that checks if you're clicking arrow keys or WASD. It could check whether or not each of those keys are individually either held or not, and decide what the character what should do or not to do. But there's an alternative to that. Unity has an input manager that defines various buttons and axes, which can be found by name. For example, it has an axis called horizontal, which is represented by the AD keys or the left arrow keys. Okay, so instead of manually have to be like, okay, the user click A, S, W, D, up arrow, left arrow, Unity already has built-in axis stuff. Okay, cool. Let's get started. Add the following lines to the update method. Inside the update method. Alright, so we can basically just copy and paste this. It's better to write it, though. It's better to write it, though. But in the update method, we will make a variable. But we're just going to copy and paste it for the tutorial's sake. But it's better to write it in the long run. So float horizontal input.axes horizontal. So we should probably do vertical ourselves, right? Float vertical equals input. Oh, it doesn't autofill? Oh, it sucks. You might have to get a plugin or something. I'm guessing vertical? Let's see if I'm correct on this. So we're putting this in the update method because we want this variable to update all the time because we want to see the input all the time. If we were to put this in start, it would only get set once, and then that's it. We can't really update it. All right. What does this line do? Creates a new flow variable called horizontal, which has a variable equal to the result of the call. In other words, variables are a way of storing data. Yes, easy. In Unity, input access return a number equal to -1 and 1. This type is called a number between -1 and 1. This type of is called a float, so it means it has decimals. Yep. Equal sign. Okay, just equal sign. Alright, simple stuff. Let's just about the code you're doing it in a little bit more detail. You have an int class input. You're drilling into that to find class input. You're drilling into that to find the method called getAccess. Okay. So input is a class that's already defined by Unity, and then you're getting there a method in that class called getAccess. I mean getAccess. access. Unlike start and update, get access as a parameter, which is horizontal or vertical, and then returns a float. Okay, perfect. We did that vertical. Cool. So we did this too just now. Mark as complete. Make a vector. So vector is like a directional object. 3D space. Okay. So we want to claim a vector 3 variable. Okay. Let's write it ourselves. I wonder if there's a thingy to make it easier to write. Unity code. Let's see. Visual Studio Unity Helper? Unity IntelliSense. Oh, here's extensions. Code completion. We want code completion. Oh, these are cool. Alright, so if you're in Visual Studio, you could go to Tools, Extensions, and you could search for Unity. Oh, these are mine. Online. Unity. UNITY3D. Doesn't really help. Going off on a tangent a little bit. Visual Studio Unity 3D autocomplete. Oh yeah, it says miscellaneous files. Okay. So if you wanted to autocomplete your code for you, it can happen when you open your C# from another folder instead of opening it. This can happen when Unity crash or fix part 1. Download and install Visual Studio Tools for Unity. I guess we need Visual Studio Tools for Unity. Do you just follow both Unity calls? Edit preferences, external tools. Edit preferences. External tools. Visuals. We want to make it Visual Studio. All right, so you want to set the external tool of your Unity to open in Visual Studio. So I have to find the location of my visuals. File location. Open file location. It is in Microsoft Visual Studio. So program files 86, Microsoft Visual Studio, 2017 community, Commons 7. IDE. Perfect. Now, if I close this and I double click the script, it should not say miscellaneous anymore. The C# project assembly C# targeting.NET framework 4.17, which is not installed on this machine. To proceed, select the option below. Change the target to... Yeah, we can download the target package. C# assembly C# targeting the network for this purpose, which is not installed on this machine. Okay, so I could use it to, I could just use the older version. Or we just update. The project will not change though. I guess we could download it. Whatever, I'm not going to download it right now because we're in the middle of this, so we're just going to use the current version that I have. Perfect. Now, we see that it's no longer miscellaneous here. So now if we were to, let's see if it autofills this. Input dot get at, now you see everything. Perfect. Really good. Really good. Control Z. Nice. There you go. We just fixed Unity and Visual Studio compatibility. Perfect. All right, now we want to make a variable vector3. Vector3 M movement. The scope of the variable, blah, blah, for example, both flow variables you just declare horizontal are in the scope of the whole update method because the coded block is with. Okay, so basically what it's telling you is we want vector3 M movement to be basically a global variable around the entire script. So what does that mean? So that means that these two variables can only be called, like, are only seen by update. Start does not see these two because they're declared inside update. If I were to declare a variable in start, update cannot see it. I had a giant problem when I just started making my first ever learning Unity on my first year of college, where I had a variable here, like say like something like that. I had a variable here, and then I was trying to call it in update, but update can't see the variables in here. The way you could see it, like we're doing right now, we have to make a variable outside of both. So a global one. So vector3, like that, autocomplete, M underscore movement. Boom. It wants capital M. Okay, I'm sorry. Perfect. Naming convention. Okay, man means this is part of something called a naming convention. Yeah, so I want to know. Why is it M underscore movement? I know it's a naming convention, but they all start with a lowercase letter, but subsequent works with uppercase letter. Yeah, okay, I know that. But why is there an M under this? Yes, okay, that's usually for... The exception to this is non-public member variable to start with M underscore prefix. And all words start with uppercase. It's called Pascal case. Oh, okay. So basically, the Unity coding convention. Okay, so basically, if you have a variable that is not declared inside of a method, basically it's global to the entire file, you want to put M as a member. It's a member variable. So you put M first, and it's capitalized after. All right, that's just naming convention. It's good to know naming convention. Makes code easier to read because everyone could see what's going on. All right. Set the values of your variable. Now that you have a variable to store the movement of the character, you need to set the value for it. Since this could change every frame, you need to update every frame, so you should go in the update method, okay? So this is XZY, right? Or is it XYZ? No, it's XYZ. XYZ. The movement vector now has a value of horizontal input as X. So yeah, X, 0 in the Y-axis, because we're not ever moving up or down. We're not ever moving. We're not jumping, right? We're not jumping. So space would change this, but we're not pressing that. We're just moving. We're moving left or right, forward, back, never actually up. So that's why it's 0. Okay, cool. Now you need to fix a small problem. The movement vectors being made up of 2 numbers. They can only have a maximum of value of 1. If they both have a value of 1, then the length of the vector known as magnitude will be greater than 1. This is the relationship between the triangle described by Pythagorean's theorem. This means that your character will move faster diagonally than it will along a single axis. In order to make sure this doesn't happen, you need to ensure that the movement vector always has the same magnitude. You can do this by normalizing. Normalizing the vector means keeping the vector's direction the same, but changing its magnitude to 1. Add in the file of script beneath the previous line you wrote to call it. Okay, so normalize basically means... Normalize basically means that, like, you prevent your character from moving faster diagonally. So that's what normalizing means. It makes it fit in the Pythagorean theorem. All right. So now we're going to go back to the code. And we're going to set M underscore movement equals to... What was it? Oh, not equals, set. Okay. So you set a vector. That's set. Yep. To horizontal, autocomplete, 0 float, because it needs a float variable, and vertical. Semicolon, and then after that, you want to do M underscore movement dot normalize. It's a method, so it needs the parentheses with no variables. Perfect. Now we have to set up the animated component. Now that you created a movement vector, there are some other jobs that you have to be done every frame. You need to construct the computer to tell the animated component whether or not the character is walking, get a rotation for the character from the player input, apply movement and rotation to the character. Okay. Identify whether there is a player input. If there is any player input, then your character should be walking, and if there is not, then it should be idle. To start off, you need to write a line of code that determines whether or not there is horizontal input. Okay. Add the following code after the line normalizing the movement vector. Okay. Bool has horizontal input equals math f, which is... Oh, what did I just do? Nani? What? We just went to the other one. What? Resume. I don't know what I just did. Anyway. So we have to make this variable. Math f is math float, I'm pretty sure. So if it's not horizontal, this means not. Let's see what it says. Here you're creating a bool variable. Well, that could be either true or false, and calling it has horizontal input, then setting your equal to the return value of the method. The method is called approximately, and it's from the mathf class. It takes 2 float parameters, returns a bool. True if the 2 floats are approximately equal, and false otherwise. So in this scenario, the method will return true if horizontal variable is approximately 0. But wait, there's another character in the line that you haven't encountered before. The exclamation mark, which it's the negation, so it's not. Inverse it. Setting true to false and false to true. This means that the hazard is being set to true when horizontal is not approximately equal to 0. In other words, horizontal input is true when horizontal is non-zero. Okay. So basically, this checks so okay, so math f approximately checks if the horizontal with variable is 0. It's comparing it to this number right here. So if this is basically this, then it's true. Right? But because we want to move when we're actually clicking the button. So if this is not 0, then this will return false, right? Because it's not 0. 0 means not moving horizontally. But because we want it to move when it's not 0, but this returns false, we want to reverse that and make it true. So when the character is moving, this returns false, but because we want it to be true, we negate it. So horizontal input actually exists. We're moving. All right, so bool has horizontal. I don't know how to spell horizontal. I'm trolling. Has horizontal input equals to negation of math f dot approximately. We bring in the horizontal value, comma 0f. Boom. And I'm assuming that's gonna be the opposite now, where we're gonna do vertical, right? Vertical input. I'm assuming it'll be the same. We'll see if I'm correct. Math f dot approximately vertical, comma 0 floats. The f means it's the 0 is basically a float value, which means it has decimals. All right. Math f approximately vertical. Perfect. We did it. All right. So now we have to decide if we're actually walking. All right. This is the part that I know because I know how to code. Okay, so now we want to make a variable. Remember that is walking variable that our animation is going to use. So is walking is true when has horizontal, or this is the or sign, has vertical. So we're setting is walking is true if this is true or this is true. If we did this, that would mean both have to be true, which is not always the case, because you could be walking left and horizontally, up, forward, and left at the same time, like diagonally. This would never be able to walk diagonally. I mean, this would never be able to walk in one direction. You would always have to be walking diagonally. But if we do or, then you can walk in any direction or diagonally or whatever. So boom, that's pretty good. Pretty good, pretty good. How easy it is to see. Should I make my font bigger a little bit? View. I think it's a good size. Control plus. I forgot the shortcut to make it bigger. Visual Studio font. Environment general. Tools, options, environment. So I go to tools.
You take the red machines, the story ends. You wake up in your bed and believe whatever you
options, general.
You take the blue machine. You stay in Wonderland.
Fonts and colors.
And I show you how deep the rabbit hole goes.
Let's make it 12. All right, that's better. That's easier to read now for everybody. Looks a little bit big for me, but it's fine, I guess. Wait, let me make it. I think it's too big for me. I feel like I'm blind. Let's do 11. All right, 11 is a good. Well, nice. We increase our font size by 1. That's fine. All right, it's good. All right, now that we have this, mark as complete. Creating variables to store a reference to animator component. Okay, next you need to tell the animator component whether or not the character should be walking or not. But hold on, you need to do something special to access the animator component. When you didn't need to do it, call methods on them. It's because okay, so static methods are methods which are called on a class's type rather than an instance of that class. So basically, how do you describe this? It's like a coding thing that you learn. There's no need to have a single instance of the input class in order to determine access values, because input is more of a global concept. True. As such, the methods which obtain those values have been made static. Likewise, the mathf class is full of helper methods which help another method perform its tasks, which don't involve any specific data for a specific instance of mathf. So those methods have also been made static. So basically, static methods, how do you describe it? So basically, static methods are methods that are inside which are in a class, but they you don't have to declare that object. How do I describe this? What is a static method? A static method is a method defined as a member of an object, but is accessible directly from an API object constructor rather than from an object instance created via the constructor. So it's basically saying that a static method, like for example, right, we have mathf. Mathf is the class, but we don't have to do like var mathf equals to new mathf. This means we made this object. This means we made a mathf object, but we don't have to do that because mathf has static methods that can be called by just calling the class name. Basically how you could describe it. We don't have to instantiate the mathf object, right? We just have to call the mathf class because these are like basically static. They're global to use. I hope I explained that correctly. Simple concept that you forget how to describe. All right. So now we have to store a reference to the animator. Okay, complete. All right, so now we have to make a variable for the animator. All right, so it's gonna be up here. Animator m_animator. Oh, bad autocorrect. Ah, perfect. Mark as complete. So our code should look like this now, which it does, which is good. Set up a reference to the animator component. So this should be in the start. Yes, okay. So now we want to call get component animator. So So basically, we have this. So we want to call. So this guy, right? Remember, he has. Let's click on him. John Lemon. Let's click save just so we save. John Lemon has an animator component, as we see right here, right? So we want to call this. He has a lot. He has transform. I mean, he has transform. He has animator. He has rigid body. He has capsule collider. So he has all these things on him, right? So we want to get this component animator. So I'm getting. So we want to do m underscore n. So we want to call this one time, right? If we do so, get component, the type goes into this. This will be the type of the. It'll be type animator. Do I need to do this? Or do I not need to do that? Oh yeah, I do. Okay. Perfect. Now I'll describe you what you see here. You're assigning a variable. Okay, so this is literally teaching you how to like code actually. You're assigning a variable to this. Get component is a static function, I'm pretty sure, of the Unity stuff, or a built-in function of Unity. Their angle shape, the name of the method, yeah. Their angle. So this is the variable. This is the name of the method. This is the angle shape backwards around animator before the parentheses. There are angle shaped brackets around the animator before the parentheses that you have encountered before. The line ends with a semicolon. Okay, now it tells you what it means. Okay. Yeah, get components already a method that's available based on mono behavior. So it might not be static. I don't know if it's static, but whatever. It's available to you globally if you have mono behavior. As part of the interface. Right? Yeah, this is an interface. So yeah. All right. So normal parameter. Yeah, these are type parameters. In this scenario, get component needs to know the type of the component you're looking for. You're looking for an animator component, so the type parameter is animator. The line of code saying get a reference to the component of type animator and assign it to var. Okay. Yes, so I was right. Assigns the variable. This is assigning the variable. This is the method that gets the type animator, and boom. Usually this means that it's returning like. Usually these use like lists. These are from lists. Like when you declare a list, you usually use these type of types. Anyway, going off on a tangent. So now we have to set that is walking. All right. So now, cool. So now we have our animator, right? So now that we have the is walking variable, we want to set the animator. Remember we made the animator is walking variable. Now we want to set that to is walking. So we're going to do m underscore animator. It's global. It's a member. Dot set bool, which is one of the variables we made. And the first one goes. The first one is the one we declared is walking in the animator, and this one will be our variable. Int ID. Interesting that it says int ID. We're taking a string. That's interesting. That's weird. It says, I guess it could be a string. I guess it could be a string. That's weird. It says it takes a string name. Oh. Okay. Oh, so it changed. It could be either an integer. It could be anything. Okay. So yeah, now it updated to being a string. See if you hover over the method, it tells you if it's a string, what the parameters are supposed to be, the type. So yeah, it said int before, pretty sure, or maybe I'm losing my mind. Anyway, so we did that. We're looking good. Create a rotation for your character. So now we're actually be turning the character in the direction that we're walking. Is that what we're doing? Yes. In this game, the character should only be able to walk forward, and so needs to face in the same direction it's moving. However, if John Lemon flips quickly to the desired direction, it's going to look really weird. Yeah, if you go. All right, so we have to a slightly easier way to frame the blah, 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 how fast the character should turn. So public float turn speed. Whoa, okay, we're gonna have to talk about this. Okay, so we're making a public variable called turn speed. Public float turn speed. If it has to, so public means encoding that it has access from everywhere. It's not a private variable. Private variables are hidden to the class. Public means that it could be called from outside if something is calling the script. But public in Unity means that this variable will appear here. So if it's public, it will appear here in the inspector. So you could easily just change the values really quickly. Okay, so calculate your character speed. Remember, you need the characters to face in the direction of movement. All transform components have a forward vector, and so it's a good intermediate step would be to calculate what you want the character's forward vector to be. Add the following line at the bottom of the update method. Vector 3 desired forward. So we're making a new variable. Let's just copy this. This is a big one. I guess it'll describe. Oh my god. This one goes here. Vector 3 desire forward. Vector 3 rotate. So rotating towards X. Oh, this is interesting. Let's see what it means. Current. Oh, target. Speed and then magnitude. Okay, let's see what that means. See, this is good to learn. A lot of Unity stuff requires this type of math. Desired forward. Okay. It sets to return the method called rotate towards. Okay. Which is a static method. Rotate towards takes 4 parameters. First 2 are vector 3s and are the vectors that are being rotated from and towards. Okay. From to. Okay. The co-star will transform forward and aims for the M movement variable. Transform.forward is a shortcut to access the transform component and get its forward vector. So forward is straight. So forward, right? And movement is the direction that we're moving. So left, diagonally, this way, that way. The next two parameters are change between the starting vector, the change. The first change in angle in radians, and then the change in magnitude. The code changes the angle by turn speed time.delta time, and the magnitude by 0. Time.delta time since the previous frame. Time.delta time is the time since the previous frame. So why do you need to multiply the turn speed by that? Update is called every frame. So if your game's running at 60 frames per second, that means that this message should be called 60 times in a second. That would be a very small change each call. So that over 60 frames, you get the change you want for a second. But what about a game running 30 frames per second? Only half of the methods are called. You don't want the number of frames per second affecting how fast the character turns. That's not good. Okay. So we want to times it by delta time. So it's like universally through any frames that it's running, it's the same speed. And what is magnitude? Doesn't really say what the last one is. Magnitude by 0. Alright, it doesn't really say anything about magnitude. Let's see. Vector 3 magnitude. It's good to understand what it is. The length of the vector. If you only compare magnitudes, the length of the vector is the square root of. Shouldn't understand what this is. Max magnitude delta. Max magnitude delta unity. Oh, here. Perfect. Magnitude is about changing the length of the vector. The vector will be rotated on an arc instead of being interpolated linearly. Okay, so if it's not 0, then it starts going more like... I think basically it says that if it's 0, it goes into an arc. If it's not 0, then it starts going more like jagged edges. That's what I'm assuming, but maybe they'll describe it later. Alright, it's good to understand what the code does, so next time you need to know, you know. Alright, turn speed wants to be 20F. Okay. Boom. Alright, now that we have a vector for the direction you want the character to face, create a store of rotation. Next, you need to use the vector to get a rotation and store it so that you can use it whenever you want. You're going to store it like you did the movement vector. Below the line declaring vector 3 movement, add the following. Okay, so under this, quaternion. So it's for rotations. And that rotation. Quaternion. Wait, M. That means it should be global? Oh, yeah. Below the vector free call a movement at the following line. Oh, so so we declared the original rotation. I'm assuming. Like that. So you don't do it here. It's the identity, right? You begin with the coordinate a default value. Normally variables are part of the class rather than part of a specific method, blah, blah, blah. For example, vector 3 default is x, y, z, all set to 0. Same as true quaternion. However, while a 0 vector makes sense, a 0 quaternion does not make as much sense. Setting the value of quaternion identity is simply giving it a value of no rotation, which is more default. Okay, so... Okay. So here you're just giving it a default value. Because... You're just giving it a default value here, I guess. I don't think you need it. I don't think you need to add this part. Because you're going to set it anyway. Right now. Like this. But I think it because the default to your rotation is still default. I don't know. you're giving the quaternion a default value. Normally, variables are a part of the class. Variables that are part of the class rather than part of a specific method are set to their default value when an instance of the class is created. For example, okay. Oh yeah. So these variables automatically are given a default value. Like this will be 0, 0, 0, right? But apparently the default value for this is weird, so we just use this as a default value. All right, whatever. And here we're setting the rotation quaternion look quaternion, which is the class, the struct. Look the method look rotation. Look at this. Interesting. So it tells you the speed from where you're starting, from where you're looking, and then your rotation will be equal to look rotation. Interesting. So this is giving you where to look, and then this is telling you look here. This is where to look, this is to actually look. Okay, look here, and the speed, actually look, and we get the new rotation. Okay. All right, our script does look like this. Pretty straightforward. Actually, where did they add the float speed? Oh, right here. Okay, that's fine. Same spot. All right, pretty good, pretty good. Apply movement and rotation to your character. See, something like this, you're gonna have to just memorize. You know what I mean? It's like, you have to just know, like, you just have to know from like a tutorial like this that you have to rotate towards, you have to look rotation. Let's quickly relapse. Review. Horizontal, get horizontal axis. Vertical, get vertical axis. Movement is a vector. You're setting it to the WASD, and then you normalize it, and then you get the horizontal input, vertical input, and then you get is walking. You set is walking to animator, and then you get this part. This part is the hardest part. I think this part is the hardest part because you have to understand what all this means. Where you're starting from, where you're rotating to, how fast you're rotating, and this is just stays 0. And then look rotation is, okay, you got where you're going, actually do it. Actually rotate. Okay. Cool. You should always use this as, you should always use, like, once you finish this script, use it as a reference for like your next project. So you already have like movement controls, you know what I mean? Right here. Anyway. So now we want to do the rigid body. Cool. Add the rigid body variable. And then you're gonna in the start, you're gonna get the rigid body just like we did with animator. Let's do it faster. Speed this up a little bit. We're almost at the hour part, and we're only like 60% of the way done. Right now that we have a reference, we have to make the walk animation. Okay, so now we're making a new method. So when you're in Unity, this runs once, this runs every frame, right? If I make a new method, void on animator move, this doesn't do anything until I call it in update or at start. Probably it's going to be an update. We'll see. This method will apply your motion. Okay, mark as completed. We made it. Movement. Let's start with movement. Now I have the following the on animator move method. Rigid body that move position. Okay, what does this mean? Another fairly completely line code, but again, there's very little that completely new to you here. First, you're using a reference to rigid body, yes. And it's calling a move position method, yes. And it's passing a single parameter, its new position. Okay. The new position starts off with the rigid body's current position. So yeah, your current position. The new position starts off the rigid body's current position plus movement times m animator delta position. What does that mean? The movement vector multiplied by the magnitude of the animator's delta position. What does that mean? The animator's delta position is the change in position due to the root motion that would have been applied to this frame. You're taking the magnitude of that length of it, and multiply by the movement vectors, which is the actual direction we want the character to move. Okay, so this is where our current position is. This is where we're moving, and this is just so the animation looks normal. The animator's delta position is a change in position due to the root motion that would have been applied to this frame. Okay. Taking the length of that and multiplying it. So I think this is like the per frame stuff, I think. Okay. So remember, our vector 3 is where we're moving to. Is where we're moving to. I mean this one. So this is us actually moving our body. Okay, so okay. So at movement is where we're actually moving. Like our character is going left, right, up, down. That's like the actual movement, the location we're going to. I forgot. This desired forward stuff is only pure just rotating. Okay. So just keep remembering what you're doing. All right. So let's see. So now we want our rigid body. M underscore rigid body dot. What was it? Move position. This is the actual movement. Move position. And now we see the variables, right? It is vector 3 position. So this will be one giant thing. So we have, let me try to remember, M underscore movement. So that's where we're actually going to go. Plus. Then we had... Oh, no. Our current rigid body position. So underscore rigid body dot position, right? Yes. And we add to that M underscore movement. So the direction we're moving to times the animator dot, this part I don't know, dot delta position dot magnitude. That's an interesting line. So usually in all your games that you make, this is how you move. You move the rigid body. And then you can start customizing all this. So basically you can make like, you could change the speeds of stuff and all that stuff by playing around these variables. Like you could change how fast movement works, how fast rotating works, all that stuff. Anyway. Mark is complete. And then we have to do the rotation. Okay. So this is the same thing. So we're doing instead of move position, move rotation. This one's pretty easy, just rotation. Well, this one was pretty complicated. Not bad. All right. One thing you need to do is change your update method. In the previous tutorial, you learned about update loop used for rendering and fix update loop, which runs physics operation. You made sure that the animator runs in time with the physics loop to avoid conflict between physics animations. However, you're overriding the root motion on animator move, which means that animator move is actually going to be called in time with physics and not rendering like your update method. The movement, vector, and rotation are set in update. If on animator move gets called first, then you'll have a problem because quaternion without a value does not make any sense. To make sure your movement, vector, and rotation are set in time with on animator move, change your update method to a fixed update method as follows. Another special method that's called automatic unity but this one is in time with physics. Instead of being called every rendered frame, fixed update is called before the physics system solves any collisions and other interactions that have happened. By default, it's called every 50 times. By default, it's called exactly 50 times every second. That's it. Interesting. So all physics, movement, gravity should be called in fixed update. Update loop is used for rendering. Fixed update is used for physics operations. That's interesting. I actually didn't know that, actually. I remember last time I was working on this, I would put everything into just update. Alright, interesting. So fixed update. Alright, so this is not called by anything yet. Alright. That's good to know. So now this will be fixed update. Alright. So this method is going to be called outside of the script, apparently. Alright, the script is done. Cool, cool. Mark as complete. And now we actually have to test it. Cool. Remember C# in order for your method to be declared in class doesn't matter, so your methods may be arranged slightly differently. Save your script. In order in C# the order in which all your methods are declared in class doesn't matter, so your methods may be arranged slightly differently. Yeah, okay. Save your script. Then give you a hearty pat on the back. Now it's time to go back to test your work. Nice. Salute. And the plan moves to John Lemon. Cool. Okay, we're just adding the script to John Lemon. Okay. So now we go back to Unity. We have John Lemon here. Add component. Or actually, we could just add component. We go to scripts, player movement. Or we could just do this. You go to scripts, click on John Lemon, drag player movement. I mean, we have to, no, you can't do that. Because if I do that, I'm only adding it to him. But we want to add it to the prefab of all John Lemons. Okay, so yes, that was almost a mistake. You want to add it to this. Okay, cool. We have to add it here. But you can still drag it here, but it's fine. Boom. Player movement. Perfect. Then we want to save. Alright, so then it just wants us to save and go back to normal view. Click on John Lemon, click F. Nice. And now the script is here. Good. It's on the prefab. Adjust your view settings. Select the game window. You see the game window scaled at the top. Game. Click on the aspect ratio. It says free aspect. Disable the low resolution ratios. Okay. Game, free aspect. Disable that. Why can't I disable low aspect ratios? Click on the aspect ratio. Drop down says free aspect. If you can't disable the box or is already disabled, then don't worry. That won't affect the finished game or should automatically configure to your monitor. Okay, so it automatically configures to your monitor. So if I click play. Oh. He just stopped for a second though. That's cool. It's not the smoothest. There's like a little... yeah, it's good. There's a little jitter if I went left to right. It like slows down. All right, just testing it to make sure it works. Always test your code. What I'm interested in... Oh yeah, there it happened again. He stops for a second. Okay, so there's a little bit of an issue. Hope they... Oh. What I'm interested in is this function on animator move. Is that declared? Maybe I skipped that part. This method allows you to apply root motion as you want, which means that movement and rotation can be applied separately. Okay, so this is like also declared already. It's already declared by Unity. Okay. Alrighty. So last check. Alright. There's that weird little like break when you turn from left to right, but other than that, the code looks pretty good. Okay. It's interesting that the character does that. See how he like stops for a second? I wonder what's causing that. Is it the animation? I'm like debugging, but I wouldn't really know how to fix that. See how it does that? I wonder if it's happening like that for you. Alright, this is how I could test it. Ready? So if I just literally just copy paste their entire code. This is literally their code. Alright, I literally copy pasted their exact code. Now I click, now it's updating. Play. Yeah, it still does it. Okay, so it's a bug in their code. I don't know if you would consider it a bug, but I just don't know what causes that at the moment. I hope they address it. We'll see. Anyway. Not bad. Alright, so that part is done. Summary. This story, no worry, coding experience. If you have no coding experience, everything, and understand everything easily, well done, but not. Don't worry if you're struggling. Okay, it's fine. Markcast complete. Alright, so we finished this part. It took an hour 13 minutes, so they're pretty accurate. It took an hour. But yeah, so let's get into the next part. Alright, guys, let's continue our John Lemon's Haunted Jaunt project. Now we're in the environment section. We just finished character part 2. And you guys, and before we start the environment, remember at the end of part 2, which was literally like a minute or 2 minutes ago in the video, where the character, when he was going from left to right or up to down, was like jittering sometimes for like a split second. He would stop, play idle animation, and then start walking again. So like he would go left, right, and then he would stop for like a split second and move again. So that was like a movement bug, and I figured out how to fix it, sort of, kinda. So I'll show you what I did. Let me show you what it looks like now. See, now look. Now that bug will never happen again. See? It would have literally happened by now if I didn't fix it. So now I'm going to show you guys how to fix it in my way. I did a little bit of research. Yeah, it looks good now. Looks very good now. Perfect. So the way I fixed this was, I added 2 variables. I added an idle time variable and a timer variable. So idle time variable basically means that the value is 0.4, which means that in 0.4 seconds, play the idle animation. And you'll understand what that means. So here, this is the part of the code that I also changed. This part with is walking. After we get is walking. Before it was setting just animator to, it was setting animator.set bool to is walking. So instead of false, instead of true, it would be is walking, which makes sense. But there's some weird, I wouldn't say it's a bug. I would say it's an interaction that happens with get axis horizontal and get axis vertical, where when you're going from left to right or right to left or up to down or down to up, there's a split moment in time where it actually hits 0. You see how it says here? We don't want that to say, if it hits 0, that means you're not clicking it. But for some reason, this actually does hit 0, even if you are clicking it. If you're like literally changing directions from like left to right or up to down, down to up, right, left, right? So I added a timer. So this is what I did. So now we have is walking. That's just, your code is the same. Now here, I do if is walking is false. This means is walking. So this means is walking is false. So if is walking is false, activate the timer. Timer equals to this means plus equals, which means timer plus itself plus something. So you could just write timer plus. You can write timer equals timer plus delta time that delta time. Or a shortcut would be timer plus equals time that delta time. It basically means like you're adding itself plus this. So this is basically just how to make a timer in Unity. Time that delta time is just basically, think about it, just seconds. So if the timer is greater than idle time, which is 0.4, which means that if timer ever goes above 0.4 seconds, we play the idle animation. We set is walking to false, and then we set the timer back to 0 because we want to reuse the variable. So this basically means that if is walking stays false for more than 0.4 seconds, play the idle animation. But if it was just like a glitch and is walking was only false for like literally a split millisecond, like a millisecond or like 0.1 of a second, then ignore setting it to false, keep it as true. So that basically solves the issue of this becoming 0 for some reason for like literally a tiny, like a frame or whatever. You know what I mean? So because of that, we fixed it now. So now the idle animation has a little bit more logic. It basically, like I said, it will only play the idle animation if you stop moving for more than 0.4 seconds, right? If you didn't stop moving for more than 0.4 seconds, then you're still walking. So keep playing this. So this is how I changed the code. You don't have to adjust your code, but for future references, if you're ever doing another project and you ever have that weird bug, that's basically how you fix it. You have to make sure that you don't play the idle animation instantly. You have to give it some time. Because you know, like when you're walking in the game, you know, you got to slow down, stop walking, right? Without this code, you stop instantly. And that was the problem. It was stopping instantly. But now it looks good. And we're ready to continue. But if you have any questions, leave them in the comments. I will answer it. But yeah, let's go. Let's go into the environment. All right, add the environment. And the previous story, we finished making the character. Now your character can move around, but currently doesn't have anywhere to explore. True. Now we're going to add environment to scene, light it correctly, and add, okay, this is the hardest part for me when making games. It's easy to code a game. Well, I wouldn't say it's easy, but it's hardest to design the level, make it look pretty, make it look nice. That's really hard, especially if you're not like an artist by nature. Controlling environments in Unity is a process that can be very wildly depending on the type of game. Yeah, very, very wildly. True. Generally involves instantiating multiple models by dragging them into the project window. Okay, just dragging and dropping. Yeah, see, creating game environments can be very labor intensive. So yeah, it's really hard, really annoying, really tedious. Make it look right. All right, in the project window, go to Assets, Scene Folders, and double-click the main scene to load it. Okay. Pretty sure we already did that. Main scene's already loaded in. So the main scene's already loaded in, but it basically wants you to make sure we save. Go to Scenes, Main Scene. But the main scene's already loaded in, so I'm not sure why he wants us to do that. Okay. Assets, prefabs, level, prefab. Drag the level prefab from the project into the hierarchy, instantiate it. Alright, so they basically already gave us the entire level. So you go to Assets, Prefabs, Environments. Oh, level. Oh, we have to go back to Scene? My bad. Make sure you do it in Scene, what's happening? Whoa. Okay, there it goes. Had to load for a second. Alright, so you can move it around. I think we could just place it wherever. There's a lot of stuff in here, because I already made it for you. Alright, so don't be intimidated. Just drag it in there. You see all these lines. That's just all objects. And all their components, anyway. Next. Position the character. Now that you have your environment in the scene, you need to position the John Lemon character in the correct place. In the inspector, transform component negative 9.8, 0, 3.2. Does it tell us where to put the environment, though? Does it want us to put it at 0, 0, 0? Let's put it at 0, 0, 0. Doesn't really say. Okay, let's put the environment. So the level, put it at 0, 0, 0 in X, Y, and Z. And then go to John Lemon. Looks pretty cool. Then go to John Lemon, and they said... negative 9.8, 0, negative 3.2. Negative 9.8. Negative 3.2. Does that look about right? Yes, perfect. So that does look about right. Yeah, that's exactly where he starts playing in the game. Perfect. So yeah, you want to make the level at 0, 0, 0, so it's literally in the center. And then you move John Lemon to negative 9.8, Y 0, negative 3.2. Perfect. The camera is still not attached to John Lemon, so we can't really see anything. But they'll probably address that soon. Alright. You want to save, enter play mode, see your changes. The camera isn't quite where it needs to be. But there's a whole... Yeah, see, the camera's not where it quite needs to be yet. So we're not up to the camera yet. Alright, so make sure we click save. We could move the camera, though, if you want to. Just so you see the game. Just drag the camera with this tool, move tool. Just so we could see. Right. Now if we click game, And we click play. Ooh, now we got a game going. Nice. Cool, cool. Nice, nice, nice. Looks good, looks good. Really cool. See, coding is like making once you're making games are really tedious, but like once it gets to like this point where you actually see your product in action, it's really cool. All right, mark as complete. Lighting the environment. Lighting has a big impact on the atmosphere. Yes. Everything has to come to the direction of light. One of 2 game objects created as a default. Machine also has a series of extra outlets added as prefabs. Let's get started with the direction of light. Okay. So directional light is always in the scene. Directional light is in your scene is set to the directional type. It mimics distant light. It's like the sun. A directional light is like the sun. Placed anywhere, and you can rotate it to change the light effects. Let's alter the directional light to feel like more like moonlight and create some interesting shadows. All right, let me move this to the side so I can read it as we go. So we go to the directional light in the game. Let's go back to scene. There's a directional light. You're going to change some of the properties of the light, starting with the color. So here's the color right here. What color do we want? It gives me a red, green, blue, and alpha. Let's just color stuff. And we want to make it RGB. Okay, so when you open this little window, make sure it's RGB 0 to 255. Okay. And basically represents the color in integer from 0 to 255. Set the color property of that component to 225, 2, okay. So we could manually do it. Okay, so here would be 225, 240, and 250. So what color does this make? Ah, nice bluish. Alright, cool. This will make the very light blue rather than yellow. Okay. In the light component, increase intensity property to 2. Okay, so close this. Intensity to 2. What does that change? Oh, you see how that changed? See? 1, 2, 1. Make it a little bit brighter. Okay. Now that you can improve the quality of the spooky shadows in the haunted house, in light component, find real-time shadows property, change it to resolution property from use quality settings to very high. Find the real-time shadow property. Here. Very high resolution. Oh. Okay, so you don't have to do this instantly because it might make, depending on how strong your computer is, if you change it to really high, it'll start making your computer slower. So you can always change it at the end of your project if you don't have the best computer. Okay. Set real-time shadows bias and normal bias properties to 0.0 real-time shadows bias and normal bias to 0.01. So what does that do? Oh, okay. Not sure what that did. I made the shadows. What is that doing? How do I describe that? Is it like where? I don't know how to describe what that's doing. But that's what it's doing. I just don't know how to describe it. I guess you just play around with stuff. That's pretty much it. Let's look at right here. Maybe it does something here. It's just moving the direction of. What about normal bias? What about regular? It's like moving where the sun is. So if you look at his shadow, the lower it is, the more accurate it looks. Because like that, this is his real shadow, right? Like as you see his shadow, but if it was higher, then the shadow goes away. So this, okay. All right, so it got dark. Okay. It did get dark. What if we raise it? Yeah, that doesn't do anything. Okay. Alright, cool. Complete. Create a global illumination light mapping effect. There are two kinds of lighting in Unity which help simulate real-world light behavior, direct and indirect. Direct lighting is from the specific light source, such as the sun, directional light. Indirect lighting is the additional lighting that occurs when it bounces off the surface. Okay, like reflection. Global illumination light mapping. Okay. Light mapping simulates the bouncing of light within the scene and writes or bakes it into an asset stored within the project. This takes time but can result in really realistic looking scenes. To save some time, you can use an approximation to create a similar effect. Wait, this effect is mostly commonly created in Unity using the global illumination light mapping feature. Light mapping simulates the bouncing of light with... Okay. To save some time, you can use an approximation to create a similar effect. Go to the window menu and select rendering light settings. Now let's do this. So window, rendering, lighting settings. Perfect. Lighting setting windows to main control of Unity's global illumination features that are currently loaded in the scene and contains sometimes environment lighting, reflections, fog. In real-time lighting, disable real-time global illumination checkbox. In the mix section, disable real-time. Oh, right here. Disable real-time. That's already disabled for me. Disable real-time global illumination checkbox. In the mixed lighting section, disable bake global. Disable. In the environment section, use the circle selection far right of the skybox material, set it to none. You don't need a realistic sky for this game. You will use alternative lighting. So we need none. Oh, you see how it changes? It changes like the color of... This is with the sky. See how that looks? And then without a sky, it looks more like the actual color. Anyway. Alright, so remove that. Sun is a directional light. Okay. In the environment section, use the environment to set lighting source to gradient. Environment. Oh, here, environment. So environment source is not skybox. We just remove that. Oh, it's this color. Okay. Gradient is broken. You set it to gradient. Okay. Oh, so we're like manually setting the colors instead of going off the sky, I think. Sky, which controls the environment light that comes from above the scene. Equator, which controls the light that travels from the horizon towards the middle of the scene. Ground, which controls the light that comes from below the scene. You can think of a gradient as a big sphere that wraps around your whole scene. Set the sky color to a lighter gray, 170. Okay, so yeah, so we're manually setting the sky color, like the equator color, and then the ground level color. Instead of, so this, because the skybox does it for you basically, and then you add like an ambient color. But with gradient, you basically set everything yourself. Interesting. So we set this color to 170, 180. See how it's changing? 200. Cool. Close. Equator color 90, 110, 130. 90, 110. Seems like they're changing all the colors. I feel like they're affecting sort of the same things. It's like tones. So the ground color to black. What does that do? 0. That's not really changing anything. Okay. The ground color can add up light that will create a nice global illumination style effect. However, it will be too bright for your haunted house you're creating. You complete the base lighting of your game and use it to enhance its spooky atmosphere. Next, you'll create a mesh that helps ghosts move around the environment. So does it look better than before? Okay. Interesting. Doesn't look as spooky as before. We could actually play around with it a little bit more. Like, what if I did... where is it? Window. General. So if we click play, right? Nothing, when you're clicking play and you make a change, it doesn't save. Unless you're changing a script. But because we're going to change, like, variables... So, like, what if we went lighting? And what if we, like, played around with this? Like, what if I add the skybox back? Oh, I guess it makes it look... Doesn't really matter there. And what if I change this to... Oh, you see how it's changing? I feel like purple looks better. Okay, I'll leave it the same. Equator color. I feel like purple would look good. But you can just play around. Okay. This is the ground color. I don't see the ground doing anything. Anyway, if we just turn it off, it goes back to what it was before because variables don't save when you're in playtest mode. Alright, it looks good, I guess. So we can do like a real-time global illumination, and then you click generate lighting. So what if I did that and click generate? It said it takes too long, right? Should I try? Should we see what happens if I click the button? Alright, if you ever want to try something, click save. Okay, I saved the scene. I want to see what happens if I do it. That's it. Okay. Does it look any different? It looks a little bit different. Didn't really do much. Let's turn it off. Alright, I could just Control Z. Alright, so if you ever want to cancel something, like I said, I saved right before I did that, so I just go back to Assets, Scenes, Main Scene. Don't save. Oh, wow. And it actually does look better. Do you see the difference? Do you guys see the difference? See how it looks right now? And if I were to do window, rendering, light settings, and I were to use real-time global, and then I click generate lighting, Like, see how it looks right now? Now if I generate lighting. I mean, it looks better like this. Okay, I'm gonna keep it like this. Save. So I actually use the dynamic lighting. I don't think the game is that big. You don't have that much crazy lights, but it actually made it look darker and look, the lights look nicer actually. So yeah, I'm gonna keep it like this. But you don't have to do it. Sort of went off on a tangent. Yeah, the lights look so much better actually. Cool, cool, cool. Nice. All right. So basically, we just figured out what the global illumination does, which is good to practice. This is a practice, by the way. All right, here we go. Now we're at the next part. Adding navigation mesh. We all know the haunted house have ghosts roaming. To help our ghosts find their way, but Unity has a built-in system called the nav mesh, short for navigation mesh. In the second tutorial, you'll learn that a mesh is a collection of triangles that all fit together in shape. This mesh enables Jaunt Lemon to be rendered on the screen. Nav mesh is an invisible shape over the ground that defines the area in which select objects can move. So how do you decide which areas can and cannot move? When a game object is identified as static, the Unity's navigation system assumes that it will not move. In your game's environment that is made up of main game objects, so if it's marked static, it doesn't move. All right. You want to enable the static flag for all children as well. Okay, so basically we're going to the map and we're enabling as static. So it does not move on the nav mesh. And all its children as well. But aren't the ghosts? Isn't the ghost? Are we gonna? Where's the ghost? Can I click on the ghost? Ghost. So he's also static now. Oh, he's the only ghost. Oh, okay. We're gonna add the. Okay, so everything in the level is meant to be static. Okay, I guess that ghost taking a shower, so he doesn't move anyway. All right, that's fine. Remember, Alt click to hide everything. Cool. All right. Now that the level game objects on the children are marked as static, you'll need to set one exception. There's a ceiling plane game object in the level design that is being used to cast shadows. If you include this in the bake, the ghost might end up walking on the ceiling. Wait, what? There's a ceiling plane game object, which is the ceiling of the game, which is being used to cast shadows. Okay. If you include this in the bake, the ghosts might end up walking on the ceiling. Why? So the ceiling should not be static. Interesting. They don't really describe why, but okay. Level corridors. What was it? Dressing. Ceiling pane. Where's the ceiling pane? Oh, you see how it does the shadow? What is that though? Oh, it's the floor. But what actually is a ceiling plane? Okay, let's not touch it. What is the floor? Oh yeah, it's just the floor. Except it's the ceiling version. And it's like, and it has some weird texture where it's like see-through or something. Anyway, all right, so we want to mark it unstatic. So now it's no longer static. Cool. Save. Nice. Game looks good. Oh, mark is complete. Create a nav mesh. The process creating a nav mesh is called baking. This is done from the navigation menu. To bake your nav mesh, window AI navigation. All right, let me move this to the side. Window AI navigation. All right, here we see it on the right. And now there are 4 tabs. It's like the bake tab. Bake. Interesting. What is this? The bake settings control the details of the nav mesh, how the nav mesh will be constructed. The first settings refer to the agents that will traverse, the ghosts that will move around. So this is the radius. Okay. The only thing that you need to adjust for your game is the agent radius. The ghost roaming the haunted house will be smaller than default. Change your agent radius to 0.25. Okay. What do the other settings do? Agent height. How much vertical clearance space must exit? How close to the wall? Oh, how close to the walls? Oh, so this radius is how close to they are to the walls. Okay, that's what that means. What's this? And height means how much vertical clearance. So how much your head above? Okay. Okay. And slope is like the vertical. Okay, that's cool. All right. Oh, okay. Okay. That makes sense now. Oh wow, they could also jump. Whoa, that's advanced, man. Anyway, we click bake. Does that look about right compared to that screenshot? Looks good to me. Cool. Oh, okay, so I guess so maybe if you make the roof static, it might put this on the roof. I guess that makes sense. The nav mesh will only be visible when you're in the navigation window. When the navigation window is open. What is the navigation window? This? If you switch to the inspector tab, the mesh will disappear from the scene view. Don't worry, it's still there. The inspector tab. Inspector tab. Oh, here? Oh, okay. Oh, this is the navigation tab. Okay. Is there like a object for this nav mesh? Or just... Because how would you make multiple nav meshes? Kind of interested in figuring that out. Okay, save my scene. Mark as complete. Summary. Okay, and you can add a nav surroundings with them around. Your game is starting to look shape. Now it's time to get the camera moving. Oh, and add some post-processing effects. These are really important to make the game look nice. Mark as complete. Boom! The environment is done. So now we're going to the camera. Nice. Alright, so now we are at the camera section. So let's continue We just finished the environment, now we're on the camera. In the previous tutorial, you created your level for your game. The character can now walk around the scene, but this means that he sometimes wanders away from the camera. Yes, so we have to make the camera now. Scenes in UNITY made up of game objects have a collection of components attached to them. There's the way the scene is viewed by players is constructed the same way. To view the scene, game object in the scene must have a camera component. When a new scene is created, the game object called main camera already has a camera component. Okay. The camera points down the game's object Z-axis. Okay. It's like a pyramid. You see what's in the pyramid. Okay. When you make a game, you have a few options to make sure the camera follows the player character. One solution is to write a script for this. However, Unity has a built-in solution, Cinema Machine. Cinema Machine. Okay. Cinema Machine's unit answers all the things running the cameras, a basic summary of the system, one or more virtual cameras. These virtual cameras are managed by a component called Cinema Brain. Cinema Brain is attached to the same game object as a camera component. By default, this will be the main camera. Okay. In your game, your camera will only ever be following John Lemon, so you'll only need one virtual camera. You'll make sure that the virtual camera follows John Lemon, and then the main camera. Make sure the virtual camera follows John Lemon, and then the main camera game object will stick to that. Okay. Asset scenes double click main scene. Yeah, we're already in the main scene, so you don't have to double click it unless you're starting fresh, like you just loaded up your Unity. Select John Lemon game object. Move your cursor or scene to him. Okay, so we go to the scene, click on John Lemon, put your cursor over the scene, click F. Oops. Click F. There you go. I changed his name by accident. Control C does change that. Okay, now we clicked F, so now we're focusing on John Lemon. Now we go to Cinema Machine. Oh, okay, that's already here. Create virtual camera. There's a lot of cameras. Boom. Okay, now the camera's inside of him. Interesting. Yeah, we get that game object is created. We'll focus point. Should be right top about John. However, since you have a virtual camera in the scene, it'll have moved the game window's view, so you no longer see John Lemon in the game window. Yes. Okay. Okay, completed this. To fix it, you have to make sure the virtual camera is tracking the character by changing the cinema and virtual machine's component settings. Oh, this is interesting. Okay. So you don't have to do anything manually. It does it for you. Select the CM. Okay. And the Spectre. You just need to, there's a lot of components, but at the moment you need to focus on 3 sections: target, body, and the aim. Okay, here they are. Target, body, aim. Okay, so it does everything for you. Cool. Follow, look at. These are optional references. Follow, look at. You want to make sure your virtual camera to move. Then it needs to know how to move. Specifically, it needs a reference to the transform that it'll follow. Likewise, if you want a virtual camera to rotate, then it needs to know what to look at. Okay. The next 2 sections are body and aim. These are for how the camera moves and rotates respectively. If you're going to restrict the movement of the virtual camera so it has Lemon in view all the time but doesn't actually look at the character. In the aim section, change the drop-down menu to the top right from composer to do nothing. Okay. Go to this. Spectre. Okay, we have body and aim. Aim will be do nothing. What does aim do? The next section are body and aim. These are for how the camera moves and rotates. So body is move, aim is rotates. Okay, so we don't want it to rotate. That's why we're disabling to do nothing. Drag and drop the John Lemon game objects onto the follow. So we wanted to follow John Lennon. John Lemon. Okay, so now it's going to follow him. Okay. In the body section, change the drop down from transposer to framing transposer. Changing the body from framing transposer will allow you to control the virtual camera's position by giving it rules about where it is on the screen. To find out more about different body settings. Alright, so if you're ever making your game and you want to play around with how the camera looks, Cinemachine is for you. So you want to change body to framing transposer? Yeah, framing transposer. Okay, so now we actually manually can control it. Okay, that's what that does. Ooh, now we have all these boxes now, which is what they have. The game window should now have several red, blue boxes. These are the guides for the screen the target will be. Now you could set the virtual camera in the correct angle. Interesting. Okay, now that you're okay in the hierarchy, select the game object on the game object transform component. Set the rotation around x-axis to 45. So this x-axis rotation 45. Okay, nice. Oh, it like shows you like, I guess, cool. All right, now the camera's slowly down, looking at the camera from above. There's roughly what we're looking for. It's the power. Why did the virtual camera move when you change the rotation? This is the power of Cinemachine. You knew that you needed a more top-down angle, and then the virtual camera worked out. Okay. Most of the default settings for framing closer are fine for your game. The only one you need to change is the camera distance. Change the camera distance from 10 to 8. So in body, camera difference in 10 to 8. Oh, whoa, whoa, whoa. Okay. 8. Okay. That's it. Change it to virtual camera, the name. Deselect. Save. Alright, so rename this to virtual camera. Click save. Deselect it so it goes away. Play. Wow! Look at that. Pretty cool, pretty cool. Pretty cool. Not gonna lie. I'd say pretty cool. We have a game, boys and girls. We have a game. Hello, Ghosty. Alright, cool. Very nice, very nice. So we could actually play around the camera now too, right? If we wanted to make our own custom stuff, we could go like, what is this? I don't know what that does. So now if you want, oops, I just removed the name. Edit. I just removed the name by accident. I click Control Z. Rename virtual camera. So what you could do is play, right? So now we're playing. And now we could just manually start changing stuff. What does this do? It looks ahead. Interesting. So now the focus is ahead of me. Well, that's really cool. Wow. Okay. Look at smoothing. What does damping do? Oh, how fast it follows you? Interesting. Yeah, yeah, okay. What is this? Screen X, screen Y? Okay, we don't want that. Camera distance, dead zone width. What does that do? Oh, that's when it starts moving. When you leave the dead zone. Okay. See, now you play around, you start learning what these things are doing. This is cool. What is the soft zone? What does that do? Not sure what that does. What does aim do? I don't know. Anyway, stop. It resets all the stuff back to normal. Click away from this. And boom. Okay, that was pretty cool. Play around the camera. Alright. Sorry, we were just playing around. Hey, it's fun, you know. Ah, okay, post-processing effects. These are all the colors and stuff. Alright, post-processing is just what you do to the camera to make it look pretty. Yes, here we go. Here, select the main camera, make a layer. So, in the main camera object, it's find the layer property below. Okay, so you go to the main camera. Let's just minimize all this stuff. Layer. Okay, I see the layer. Add layer. Okay, post-processing volumes. I don't want to write that, so let's take that. Add layer. Post-processing volumes. Good. Now I could go back to main camera. It should have... Nice. Now it has the layer. Post-processing volumes. Is that what we wanted to do? Or did I troll? I have not... Okay, add post-processing layer component. Oh, wait. This camera is create a layer. You have not reassigned the main camera to this. Okay, so maybe I skipped ahead. Let me undo it. Okay, I undid it. I went too far ahead. Keep it a default for now. Now add a post-processing layer to the main camera. Okay, now it did it. Okay. So you want to add component, post-processing layer. Nice. And now the layer becomes post-processing volumes. Cool. Complete. Easy. So we don't have to set the main camera to it. Yeah, we didn't assign the main camera to it. It's still default. But we're changing the layer of this to post-processing volumes. Okay. Before you move on, set up your volume and profile. Let's quickly consider anti-aliasing. Aliasing is the edge of the object looking jagged and pixel outline. Anti-aliasing is a post-processing effect that reduces the prominence of this jagged lines. Okay, so they want us to zoom in to see what we're doing. So go into game and then zoom in. Do you want me to zoom in like this? Or like this? Right? Is that what it wants? Make sure that in the game the game view is visible. Oh no, it wants me to be in the game view. Okay. Could zoom in a little. Zoom in, it starts making it look blurry. Let's just keep it like this. Make it bigger. There we go. In the post-processing layer component, change the mode property from no anti-aliasing to fast approximate anti-aliasing. Fast approximate anti-aliasing. Okay, I did see a slight change. Yeah, you see that? How it looks pixeled? Now it looks less pixeled. It's more like a blurry to fix the pixel. Okay, it worked. Enable fast mode checkbox. What did that do? I'm not sure what that did. Okay. John is looking already better. Okay. Now that post-processing set up properly, you can move to creating your volume. Creating a post-processing volume. Create a new empty game object. Okay, so now we're going to go here. And, oh, here. Let's click save. New. Create empty object. Rename it to global post. So, and set the layer to, okay, now this becomes the layer post-processing. So that means this post-processing volumes is going to affect this because it has the same layer, I'm assuming. Change the transfer component to 0, 0, 0. This object is going to be your global post-processing volume. This global volume, okay. Post-process volume. This is the post-processing layer. Okay. So we want this to become 0, 0, 0, 0, 0. And we want to add component post-processing volume. The global volume works as a default profile for the camera it affects. Okay. We want to check this. Global. The new button to the right property. This will create a new post-processing profile. Its assets will be saved in the new folder called main scene profiles, assets scenes. Okay, so we'll make a new. Yep. Made a new folder. Now that the profile has been set, you'll see more settings available in the post-processing volume component. The override subsection refers to different effects that can override how the camera normally renders. Okay. So now we have this. Okay. Post-processing volume component. Oh yeah, it has like the add effects stuff. Okay. Adding color grading. Add effect, Unity color grading. Ooh. I mean, add effect, Unity color grading. Okay, we all see all this stuff. So you have the main camera that has a post-processing layer, and that layer is the volumes. I just want to make sure I did this correctly. One second. The main camera, the post-processing layer is the main camera. This layer here is nothing, but we change that to nothing to post-processing volumes. Yes. This stays default up here. All right, everything is good. All right, I just want to make sure everything is okay. And this, okay, is the layer and has the volume. All right. So virtual camera has nothing. Yeah, the virtual camera has nothing. It's just the main camera has the post-processing layer. And then this global thingy has the volume with this layer name. Okay. Just want to make sure I understand it for next time. All right. Okay. First you want to, okay, this is just different color settings. First you want to set the tone maps. The tone map changes the output of the final rendered frame, so it's much easier to control lights and shadows. You need to tone map the scene. Tone mapping changes the output of the final rendered frame, so that it's much easier to control lights and shadows. Enable mode checkbox and tone mapping. Mode checkbox and tone mapping subsection. Okay. Tone mapping mode. Change this to aces. Oh. What did that do? Made it dark. Aces tone mapping is an industry standard way of applying tone mapping. Oh, industry standard. Creates more film look. You'll notice that your scene looks really dark now. That's because Aces default exposure is 0. A good way to fix this is to use post exposure feature. Post exposure is a way to adjust the default exposure. In the tone subsection, enable post. Okay. In the tone, post exposure. Ah. Oh. That's how you make games super dark. Okay, let's make this one. That's cool. Cool, cool, cool. Adjust the overall exposure of the scene. Okay. Cool. So you can make your scene a little spooky by changing some colors. Halfway down the color grading wheels, okay. Called the track balls. Okay. Enable lift gamma and gain checkboxes. Okay, it's like color correcting, yes. Lift changes the color of your shadows. Gain changes the color of your highlights. And gamma covers everything in the middle. Okay. Lift is shadows. That is highlights. And this is middle. Drag the circle to center. Drag the circle in the center. The drag will slightly adjust the color in the game view. Drag the lift slightly. Okay, so it wants us to do this. So just eyeball it. Right, bottom right, upright. So it wants to go like that, like that, like that. Something like that. I wish I could make it bigger. How do I make this bigger? Alright. Doesn't look too bad. I wish I could, like, make it bigger. Is there a way to make it bigger? It's kind of hard to, like expand this? Whatever. Not bad. Pretty accurate, I guess. What can I say? Looks pretty accurate. Add the bloom effect. Bloom. Alright, so let's minimize this. Add effect, Unity, bloom. Select the all shortcut just below the section title. It will enable all the settings for bloom. Currently nothing is glowing, so intensity isn't high enough. Select the all. Oh, all. Okay, nothing really happened yet. So the intensity 2.5. Oh. Whoosh, whoosh, whoosh. Okay, 2.5. So like all light colors start like getting brighter. Just see, this is like a light, so it's becoming brighter. Okay. Currently, you might need to see some. You might see some other brighter objects you feel can also look nice with a little glow. You can have the bloom effect threshold, lowering the threshold. Wait, you might see some other brighter objects that you feel could use also, that you feel could also look nice with a little glow. You can add them to the bloom effect using the threshold property. Lowering the value adds less bright pixels. Okay, yeah. Okay. Oh. Cool. So the lower the threshold is, the more stuff that are bright colors glow. Okay. It's making my character glow a little bit. Not bad. That's pretty much it. Ambient occlusion. Minimize that. Looking pretty nifty. Unity ambient occlusion. All shortcut. Okay. Add Unity ambient occlusion. Open it. Add all. You don't see anything yet. Set intensity to 0.5. I mean, yeah, 0.5. Like Bloom, you'll need intensity to set intensity to 0.5. You'll create a nice spooky shadow in the corners of the rooms. You can spread this effect even further across the room by using the thickness modifier, 3.5. 0.5, 3.5. So if this is, what does this do? Oh, okay. So 0.5, a little darkness, and thickness. Oh, how thick those shadows become. Cool. Really cool. Nice. Vignette. Okay, same thing. 0.5, 0.3. Add effect. Open all. What did I say? 0.5? 0.5, 0.3. What does that do? Oh, okay. It's like the eye. 0.5? Okay, I made everything like dark. Smoothness 0.3. Alright. Okay. Spooky. All right. Complete. Add lens distortion effects. 35. Scale 1.1. Add effect. Unity. Lens distortion. All. $35, 1.1. 35, what does that do? Okay, why do we do that? Visual glitches at the edges of your screen. What does this do? Whoa. Why do we want 35 though? Scale 1.1. What does that do? Oh, it like zooms in. Okay, I'm not sure this makes it look that much better. Adds a little curve. I guess. This one I'm the most iffy about. Why do we want this curve? Looks better with the zoom, but like, is there a reason? It zooms in a little bit, but we could zoom in ourselves. The curve doesn't look that bad though. It's fine. What I do want to change is though, I kind of don't like the colors. I want to make it less blue. I like that better. I don't want it to be as like bluish looking. Now it looks better. Yeah, now it looks better. I made it a little bit less. Cool. Save, Control S. And summary. Before, after. Does mine look like that? It sure does. Why is his shadow on the right side? My shadow is here. Why is his shadow here? Huh? Doesn't matter. Why is my shadow in a different spot? Is it because I moved that thing before? Let's see. Ceiling. Is it because I moved this? Whoa. What is happening here? All these camera effects. Control Z. That's fine. Alright, it's good. I don't know why it's... What is happening here, though? What is this? How do we get rid of this? Oh, there we go. Okay, so... Why did it look like that? What did I have selected? That was interesting. Okay, now I actually see stuff. Question is... So theoretically, I could move the ceiling plane. That's weird. It's weird that the shadows are in a different spot. Does that have to do with the directional light? It does. Ah. All right. Oh, there you go. Okay, so the directional light controls the direction of the shadows. Maybe I missed that part. Let's try to get it how they do it. So their light is just on this part right here. Oh, that could be 0. It's fine. So their light is somewhere like this. A little bit off. More on the carpet, like this. Oh, wait, we almost got it perfect. Perfect. There you go. Now it matches. Okay, so we just have to change the direction of the shadows. Look at that. See, we're learning. We're adapting and learning ourselves. Really good. Nice. Perfect. Good job. All right. Completed. Nice. We did the camera part. So yeah, let's continue to the next part, which is finishing the game, which is weird because we're only halfway done. But yeah, let's continue. Alright guys, so now I'm going to start the next part, which is tutorial ending the game. So we're ending the game halfway through. We're only like 50% of the way done, so we're not ending the tutorial, we're just ending the game. But here we go. Set up the UI. So we just finished, I believe, the camera section. Right? And now we're doing ending the game. Okay, cool. Setting up the UI. You already done a lot for work to set up your character, environment, and camera. Yes. Now you gotta create the end game. Ooh, okay. So the end game is just gonna be like a pop-up. You have to know what you're trying to achieve. When John Lemon reaches the exit of the game should fade out and quit. But you need to be careful with this. Quitting in the Unity editor and quitting in the final built version of the game are different. First, though, you need to make the game fade out. To do this, you're going to need a Unity's UI system, user interface. Okay, UI image. A UI image can be stretched across the player's entire screen, and its opacity can be changed to create a fade effect. Okay. Alright, so we go here. Game object, UI, image. Ooh! Cool. Okay, this is added. In your scene, click on the 2D button to enable 2D mode. This will enable us to see new game objects properly. So if you're dealing with the canvas, like 2D UI stuff, then you want to go to 2D mode. Where is 2D mode? Scene 2D. Click the top 2D button on the top bar, enable 2D mode. Top bar, enable 2D mode. Oh, I was in game. I have to go to scene. My bad. Alright, 2D mode activated. Okay. And then click the canvas game object, place your cursor over the scene and press F. So click canvas over press F. Damn, I did it again. On a canvas, press F. There you go. Sometimes I like change the name. Okay, we're good here. So that's it. Now we gotta zoom in. Oh, it's like glowing because of the bloom effect or whatever that effect was on the camera, post-processing. Zoom the cameras more closely. You could either scroll the wheel or drag. Okay, I zoomed in. In the hierarchy, select event system game object. This game object has a component attached to it which works together to allow any UI element on the screen to interact with the user input. However, in your game, the player doesn't need to be able to interact with the UI. Oh, okay. So you can actually interact with the UI. The character can interact with the UI. Wonder why you would use that. Maybe like the character clicks the UI buttons in like some game. Okay, pretty cool. So delete event system. So we don't need event system. Next, you'll have two remaining objects. Okay, cool. Configure the canvas. Rename canvas to fader canvas. Easy. Rename canvas to fader canvas. Open up canvas in the inspector, and we see all these thingies. Notice that transform component is different than the ones you've seen before? Yes. Game objects that are part of the UI system need better control over their position, so you have rect transform. For a canvas at root of the UI hierarchy, the rect transform settings are read-only. Okay, so can't change them. The canvas component controls the UI. The rendering is primarily controlled by the render mode. There's 3 screen space overlay, which canvas fills the screen. All the UI elements on the canvas are rendered on top of everything. Okay, so this is like, could be like a, like say like you're in a game, you have like a health bar. So that's the overlay. Screen space camera, screen space camera, where the canvas fills the screen, but is rendered to a specific camera and is subject to distance from the camera. Okay, so you can select what camera you want it. World space, where the UI exists in the scene and is rendered in front or behind objects. Name tags. Okay, so this is like name tags. This is like health bars. Or like your health bar, not like an enemy's health bar, but your health bar that you see like in Minecraft inventory, your health, all that stuff. Any game. And screen space, I guess, is a specific camera that gets it, but I think this one's whatever. You need to stretch the image across the screen and have it rendered over the top of everything, so you need screen space. Yes, we need that. Is it set to screen space? Overlay? Yes, it is. Next component of the fader canvas is a canvas scaler. This is used an easy way to controlling the relative sizes of the UI elements. Your image will be stretched across the entire screen, so you don't need to worry about the relative scale. Click on the cog icon in the top right canvas scaler component, open it, remove component. Oh. So we don't need the canvas scaler because this is used an easy way of controlling the relative size of UI elements when they're displayed on different screen sizes. So different screen sizes. Interesting. So we don't need that. Remove. Try to get familiar with everything is. So next time you won't memorize to do all this by yourself, but like the next time you like research it or want to learn it yourself, I guess it becomes easier because now you know what you're looking at. Sort of, kinda. Final component of the fader canvas is the graphic raycaster. Yes. It determines which UI element was clicked on and send the event that element so that the appropriate component can react. The player won't interact with the UI in your game, so the component is not needed. Okay, so we remove this as well. All right, complete. The next step is to stretch the image across the screen in the hierarchy. Select the image game object, select the rect tool, or press T. Hold on. Something's funny going on here. Why is the image not where the rectangle tool is? This is because the scene window is using the post-processing you set up in the previous tutorial. Interesting. So we're going to go to the image. Use the rectangle tool. Mine's pretty lined up though. But you want to turn off the... You want to turn off all the post-processing. Ah, okay, there you go. Mine looks pretty the same with the effect, honestly. But yeah, so you could turn it off by clicking the button right to the right of the audio. See, now it's like normal. Okay. And we're not going to move it? Okay. Wait, so we're not transforming it? So why would we do that? Click the effects button in the scene and it'll turn on. Your image should now display properly. Yes. Next step is stretch the image across the screen. Select the image game object. Select the rectangle tool or press T. Hold on. So I have to stretch it across the screen. What screen? You mean like full size? Oh, they mean like this? Ah, they mean like that. Okay. So that's what they mean. Okay. Q. Nice. All right. So they tell you basically they skip the step where they actually tell you to make it larger because they say hold on. But it's fine. Okay, we did it. Okay, let's have a close look at the rect transform component. Okay. This is just telling you how the rect transform works. You can just play around with that. All right. So they have like anchors that are pretty important because anchors control how the UI looks, even when people have different amount of pixels on their screen. I could just read through all this. Well, you need the whole screen to fade. That means your image should cover the entire screen no matter what the screen shape or size is. In order to do this, you need to make sure that the anchor area is in the entire screen and there's no offset from that area. Okay. Do we have to do anything? Where are those anchor points? They're right there. What? Okay, so they're right there. Am I supposed to do anything with them, though? Am I supposed to make them... Am I supposed to do anything with the anchor points? Is the question. Doesn't really say. The position of the rectangle instead of the position of the rectangle being relative to a single pivot point on their parent, they're relative to an area of their parent. This area of the parent is represented by a rect transformed anchor. So we see those. You may see a gizmo in the scene window which looks like a flower. Yes. This is actually multiple points all pulled together. Each of these points is an anchor. Okay. The rectangle created by the 4 anchor points is a proportion of the total area of the parent. Your image is a child of the fader image, which fills the entire screen. This means that your image position is relative to an area of the entire screen. Okay. Okay, it's just describing what we have to do. It's gonna tell us what to do now. Yeah. Okay. In the hierarchy menu, select the image object. Rect transform, expand the anchor settings. Set the minimum X and Y values to 0. Set the anchor. Okay. So we're in image. We're gonna go to expanding this. Min X is 0. Ah, I see. So we wanted to make sure that those anchored thingies match the size of your box. So it scales to all screens, no matter what their pixel size is. Okay. Cool. Okay. Given the anchor area of your image now the whole screen, no offset is needed. On the image rectangle transform left. So we don't need an offset. Okay. 0. It's pretty much 0 anyway. Cool. Alrighty. The image now stretched over the screen. Oh, okay. So I manually stretched it, but you could have just not stretched it. So if I were to do this, and then I remove this. Okay, that makes sense. Okay, so you could manually do it, or it does it for you with like these anchors. Okay, I kind of rushed ahead a little bit. Unlucky. All right, so now we have the image component. Yep. This is the first property called source image, which allows you to display a specific picture. This can also be set with the color. Open the color picker, set it to 0. Okay, we want to make it black. Okay, so we just make it black? Okay. So I can just do this. Boom. And that's the fading. Alpha is the fading. Okay. So now it's fully black. Cool. Now click elsewhere in the editor and close the picker screen. Now you have a fully black screen. Yay! Alright. Yep. Screen is all black. In the hierarchy, rename your current image game object to exit image background. Rename, copy pasta, exit image background. Right click the exit image background game object and add an image component. Okay. Add 3D object, UI, image, and we rename this to the actual exit image. Nice. Now let's add the picture. The source will be 1. Source 1. Wow. So we want to do the same thing with the size, right? I'm assuming I'm assuming you're gonna do the same thing with the anchors. Right? Yeah, 0, 0, 1, 1. Left, right, top, bottom to 0. Huh? Okay. 0, 0, 1, 1. Okay, so when you set the anchors, it changes this. Okay, so if you don't touch the anchors, then it has like width, height, X, Y, Z. Okay. This is 0, 0, 0, 0, 0. Nice. There you go. We did it. Yay. In the image, so we want to preserve the aspect ratio, right? Yeah. That's why it doesn't look weird. Nice. Oops. All right, good to go. Add a canvas group component. Next, you need to make the UI elements fade in and out when you want them to. You already know what you can adjust an alpha of an image. But because there are now 2 images, you'll need to change both of the colors instead of changing it to one value. Instead of changing it with just one value. To help you do this, you need a component called canvas group. A canvas group allows you to control some aspects of all visible UI elements on the game object and all its children. Okay, exit image background, game object. Okay. So go to this. Add UI. Can't, what was it? canvas group. Add component canvas group. Boom. Easy. Change alpha to 0. Now that you're done with making the UI, let's... Okay. We only did one, right? We only did one image. Okay. This is also going to be a lose image, I'm assuming. Hit alpha to 0. Alpha to 0. What does that do? Okay, now you can't see it. Click that by accident. I unclicked it. Alright. Now that you're done making the UI, let's switch the scene back to the level. First, disable 2D mode in the scene window. Boom. Disabled. Click John Lemon object and click F. John Lemon over here. Click F. Nice. Let's rotate back around. Control S to save. Now we need to trigger the way my UI fades. Can I see the level again? Yes. Cool. Alright, creating the game ending trigger. The computer needs a way to recognize that John Lemon has exited the haunted house, so you could set the canvas group's alpha properly. A common technique for detecting when a physical object is a trigger, yes. Create empty, game ending. Alright, so we're gonna go here, create 3D object, 3 empty, rename it to game ending. I put mine, make sure it's not inside the canvas. Okay. Let's close the canvas. Nice. 18.1 1.5. 18 1 1.5. Good, let's go to it. Click on it. Click F. Now it's here. This is the game ending place. Cool. Why don't we make it further back? Like right here. Wouldn't that make more sense to make it in the doorway? Like right here. Or like right here. Let's put it right there. Anyway. Alright, now you need to add a trigger. In the spectrum acts a box collider component. Alright, so we add a box collider component. Okay. Enable the is trigger checkbox. Okay. So now we're gonna go into here, add component box collider. Nice. Now we have a little box around our invisible box. We will make it an is trigger. And now we can just resize it the way we want, honestly. Nice. You see right here. What are their exact numbers? 1 1 3.5. 1 1 3.5. Alright, that's good too. Yep. I'll put it right next to the door because it makes more sense. But you can put it here. It doesn't matter. It doesn't really matter where you put it. Alright. Alright, we made the trigger. Now we need a script to use it. Now we need a new script called game ending. And drag it into... the game object. Okay. So now we're going to go back into Unity. Go to scripts. Create new script. Call it game ending. Reload all. Alright. Reload all. It just keeps telling me to update my stuff, but I'm going to keep it the same. Alright. Updated that. Game ending, we can open it now. Boom. Now game ending is a new tab. Perfect. And before we do that, we want to go to game ending here and drag game ending into game ending. So now it has the game ending script. Cool. Time to code. All right. Remove the start and update methods. Remove the start and update. Interesting. So we don't need start or update. Deleted. Let's think about information you need. First, you need to screen to fade out. So you want to, it should be a public variable. So you can adjust it in the inspector. You could also allow it for non-whole number. So you'll need a float. The regional default fly will happen over 1 second. So 1F equals 1 second. So let's set that as default. Okay. All right. So we want public float. What do they call it? Fade duration. Fade duration equals 1F. And then we want public game object, which is the actual, which is going to be your player. It's the object of your player. Call it player. That's not assigned yet, I'm guessing. Yes. Okay. Now we have two main variables. And we are making a new method on trigger enter. So it's another one of those built-in mono behaviors. On trigger enter. Okay, collider other. Okay, so we're gonna make a method. What was it called? Returns a void. Okay, void on trigger enter. Collider other. So this is the name of the method that's built into mono behavior. This returns nothing, and the variable that it needs is a collider, which is basically the other object's collider. See this trigger, this game ending thing has a collider. So the object that's going to run into it also needs a collider, which will be your player. So I'm assuming they're going to take John Lemon, and we're going to drag John Lemon's collider into here. Let's see. But that's not yet though. Okay. To make sure that the ending is only triggered when John Lemon hits the box collider, add the following segment and on trigger between. When other that game object is player. Okay. So that's player. Okay. If other dot game object equals to player, do something. Nice. You can also get more specific. You can go like, what other that game object dot tag or dot a lot of stuff. Anyway. All right. If that equals means equivalent. Okay. Complete. And an update method. Want a member variable. Okay. Let's see what it's doing here. Okay, so what it's doing here is making, we made these two already. This is a new bool, is player at exit, so this gets set to true when our player walks into the collider. That says we're at the end game. And then this gets called when this is true. All right, cool. Let's copy the name of this variable. So I'm gonna add a variable. It has an M in front of it for naming notation. So if it's not public, and if it's not a public variable, but it's not inside of like a method. It's outside of all the methods, and you want to put M in front of it, as it's a member of everything, but it's not public. That's basically how they name stuff. So M underscore is player exit equals to true. And then we want to make the void update. And if M underscore is player exit, then we do something. Cool. But isn't this undefined right now? Shouldn't this be defaulted to false? Because right now it's set to nothing, and it's only set to true if the player is in the trigger. So right now it's checking nothing, unless it's automatically defaulted to false. I guess we'll find out right now. Mark is complete. Right, the if statement code block. All right, then we want another function called void end game. And this is going to get called when it's true. So this is just a way of organizing the code. You don't even need this. You can just write all your code for endgame, like here, like blah, 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 blah. But it just makes the code neater. It makes the code look neater. Okay. Want another variable for the canvas. So right here, all the public variables together. Now we're going to have add the canvas also. And a timer. Okay. And a timer variable. Just like that. Easy. Next end level method needs to start counting up the timer. You may remember from the player movement script there's a way of getting how much time has passed since the last frame, the time to delta time. You can set the timer equal to delta, blah, blah, blah. End level method. Okay. So I actually showed you guys this code when I was fixing that bug with walking. I use a timer, so now we're actually familiar with it now. Cool. So now we're setting the timer. Nice. And it's time to set the alpha of your canvas group. The alpha should be 0 when the timer is 0, and 1 when the timer is up to the fade duration. In order to get this value, you can divide the timer by the duration. Okay. So exit background image dot alpha equals to is it timer first? Yes. Amount of time. Whoa. Divided by fade duration. Little sleepy, I guess. Little sleepy. Perfect. So this is updating the alpha of the canvas group based on the timer divided by fade duration. So the timer, when does it stop though? The alpha should be 0 when the timer is 0 and 1 when the timer is up to the fade duration. Oh, so okay, I see. So right now it'll take 1 second to fade. So this would be 1, 2. So if the timer takes, if it's 2 seconds, divided by 2, it'll be 1, which is fully alpha. If it's 0 and this is 2, it's still whatever. If you set fade duration to 4 seconds, it'll take 4 seconds for it to become 1, which is fully covered up. Yes. Okay. So basically this says that if this is 4 seconds, it'll take 4 seconds to get fully complete. If it's 1 second, it'll take 1 second. Okay. Oh no, here. Okay, now we're doing that. Okay, yes, it was basically correct. Except now we have to just stop it. Yeah, so we wanted to actually finish the fade. Because eventually the fade will be complete, but it won't do anything more, right? Because like, if the fade duration is 4, and the timer goes above 4, yeah, and the timer goes above 4, then it's no longer gonna be changing the alpha. It'll just be stuck at 1 forever, but it's gonna keep running the code, which is bad for performance. So now we actually want to stop it. That's why we write this code. Cool. Now we actually want to stop it. And then we want to do application exit. Is it a couple uppercase? What was it? Oh, that quit. Okay, my bad. Boom. So basically this sets the alpha, and then when the alpha gets to 1, basically when the timer equals the fade duration, let's say 4 seconds equals to 4, divided by 4 equals to 1. So 4 divided by 4 equals to 1. That means this will be complete also, and then we quit the application. Hope I didn't confuse anybody with that. Now here's a problem. The method will indeed quit the game, but it only works for fully built application. Currently the game is just a project, so this won't do anything. Okay. All you need to do to... oh, okay, so... You want the player to have like a second or two when they can actually read the screen, because as soon as it fades fully in right now, it'll just quit. But we want to like increase the duration. So the display image duration. Okay. All right, we add a new variable. Okay, cool. Okay, I get it. I get it. Oh, I get it, bro. Okay, you can't copy. All right, so then we just go here. And then we add that to here. Duration? Not duration, it's display image duration. Perfect. And then we quit. I'm still interested about this, because I'm only setting it to true here, but here if it's not true. I guess this also checks if it's null. Yeah, I guess it's fine. This checks if it's null. This checks if it's true. So if it's not true, which means it could be null. I mean, it could be null. Then it still will work. I just feel like you should declare it equal to false first, but it says whatever. Seems like it works. Yeah, it seems like it works. I personally would make it equal to false, just so we know where it's starting out. You're starting out false because you're not at the exit, and then when you get the exit, it turns true, but it's fine. Seems like it works. All right, we're completed that step. All right, now we have to drag those variables into the script. Drag the Jaunt Lemon game object. And then drag the exit image background game object. All right, so this has to be a game object, right? Because here we wrote game object player. When the game object is the player, then we activate the trigger. So the player is Jaunt Lemon. So we drag him in here. Boom. Exit background image would be right here. Is it the image or the background? The image, right? Yes, the image. Right? Oh no, the drag the exit image background. Because this has the alpha. Yes, okay. Drag this onto, where was it? Game ending. Boom. Exit image background. Cool. This game will actually look good, cool in 2D look. I'm clicking a 2D button. Looks pretty cool. Anyway. Cool, cool, cool. Mark is complete, and this is summary. Nice. We did the UI. Are we going to do losing as well? I guess we're going to add losing later. All right. We finished with that part. Now we have to do the next part, which is the static observer. So the enemies. But yeah, let's continue. All right. So now we're going to continue to the next step. The static observer. It's going to be an hour long. Ooh. All right. So now we're going to set up the gargoyles. Ooh, gargoyles. We have to bring the gargoyles into the scene. So the assets, models, gargoyles. Assets, models, characters, gargoyle. Cool. Let's actually go back to John Lemon. Click F. Nice. All right, drag it into the hierarchy window to instantiate the model. The haunted house needs multiple gargoyles. Remember, a model is read-only. To make items, you need to make a prefab. Drag the gargoyle game option to the hierarchy window. Okay. All right, so now we get the gargoyle. We drag it into the scene. Into the scene, but we want to make it what's it called? A prefab, so we could duplicate it and edit it. So then we drag the gargoyle into here. Original prefab. Boom. Now he's a prefab. Now he's blue. Control S to save. Then they say we want to click on the shortcut right here. What is that? Oh, that's the prefab editing tool. Cool. This prefab is open for anything. Let's animate it. Wow. All right, so now we're adding a new animator. Okay, animator, make a new animator controller called gargoyle. Let's copy this. Okay. So we're going to go to animation, animators, add a new create, animator controller, call it gargoyle, double click it. Now we have this. Go to animations, and they already have it for us. Drag idle in there. Cool. All right, so same thing as before. We go to animations. We have the gargoyle idle. If you want to see the name, it's like this. Remember? Drag gargoyle idle in here. Okay. And then go back to scene. Click on go back to assets, prefabs, gargoyle. And now he has an animator. I got to drag the animator onto him. Animator. Click him. Okay, here. Click on him. And then no, I have to click on his prefab. Oh, I clicked on the model. Here, click on that. Yeah, there you go. So don't click on the model. Click on the gargoyle, and then drag the gargoyle. Boom. Right? Save the scene and enter play mode and see the gargoyle moving. Cool. Alright. Just making sure everything is okay. Game. Play. He's moving! He's moving! Nice. We did it! Let's go back here. Wanted to see something. Wanted to see if I open John Lemon, his animator controller. This one has apply room motion. Oh, because update mode is normal. John Lemon's is animate physics. Handled by script. Oh, okay. I was interested in why it was different. Okay, cool. What is this? Value was null. What is this? What is this? Assertion failure value was null? Where is this coming from? Post-processing. I think it was just a bug. Because we don't code any of the post-processing. That's just dragging, dropping. So you can just clear it. That's out of our control. It's something here. One of these checks. Alright, Unity, stop breaking the game. Alright, Marcus complete. Add a collider to the gargoyle. Capsule collider. Make sure we're in prefab mode. Okay, go back to the gargoyle. Click on the prefab mode. Scene. Should I just rotate him? I don't know why I put him opposite. Okay. Not sure I put him the opposite direction, but okay. Cool. What happens if I rotate the model? Oh, whatever. We'll rotate the actual gargoyle. All right. So here we want to add capsule collider. Nice. Maybe they'll give us the exact components. 0, 0.90, 0.3, 1.8. 0, 0.9. So that's like the center's body. 0. Was it 3? 1.8. Alright, looks about right. Yep. Nice suit. Direction Y-axis. Yes. Alright, complete. Create a trigger to simulate the gargoyle's line of sight. Ooh. Needs a way to spot John Lemon. So we need another trigger. So we're going to create again the empty game object point of view. Okay. So we're going to create an empty game object inside the prefab editor. Yes. So create empty game object. They called it point of view. We could just do POV, but point of view. Click on that. Add a make it 0, 0, 0, 1.4, 0.4, 0, 1.4, 0.4, and then 20. Okay. If the transfer handle is seen, windows aren't pointing down. Slightly animated because they're set to global instead of local. You can change this by clicking a handle rotation toggle in the toolbar. Handle rotation global. Oh, okay. So you want it to be local, not global. I want it to be local. Okay. Cool. Then we gotta add a capsule collider component and make it a trigger. Okay. Add component, capsule collider, make it a trigger. And now we're gonna give it 0.95. Radius 0.7, height 2. 0.7, height 2. Okay. Change the direction from y-axis to z-axis. Nice. Hey, that's kind of a lot of line of sight, by the way. Perfect. You set the collider to match the gargoyle's flashlight? Does it match the flashlight? Could we also... Mark as complete. Could we also, like... Okay, so the gargoyle is one full model. If it was made out of smaller parts, then maybe we could literally attach this point of view to the camera so it like moves with the camera. But now it's just stationary, I guess. That's fine. I have to write a custom observer script. Point of view. Alright. So add a new script. Go to scripts so it's organized. Create C# script. Point of view. We're gonna drag it in. Click this. Drag it in here. Gonna open it. It's gonna give me this thing again. Alright, good. I should just update it, but whatever. Add a class to detect the player's character. Oh, they call this observer? What did I call it? Oh, I call it observer. Okay. Oopsie. Rename. Observer. Now that should change too. Then we have to make sure we change the name of this. Okay. Closed. 1 second. Make sure this becomes observer also. It has to match the name. Alright, now it should work. This has to match the name of the file. Alright. Oopsie. Anyway. Alright, we want to make a transform public. First, you need the observer class to detect the player's character. Add the following line. Transform player. Why aren't we using game object? There's slightly different approach to looking at game ending triggers, because this will look for the character's transform instead of the game object. It makes it easier to access John Lennon's position and determine whether he is in clear sight. Oh, okay. They answered my question for me. Public transform player. And then M. What was it? Bool is player in range. Bool M is player in range. Boom. On trigger enter. if other dot, what is it now? Other dot transform. Interesting. Equals. So why couldn't we do that before? Player. Then M equals true. Good, good, good. Wait, what? Oh, this is exit. Okay. So we do on trigger exit. On trigger enter, on trigger exit. So this is the opposite. Just change this to false. Does not equal player. Oh wait, it does equal player. Oh, okay, so it's not complete opposite. It's literally the same. Oh, okay. I was thinking too deep into it. It still equals, okay. I was thinking like, oh, it doesn't detect you anymore. But this is just if you leave and it was you who left, then set it to false. Okay. Alright, that makes sense. Cool. If you enter, it's true. If you leave, it's false. Okay. My bad. Engineer, by the way. Yeah, our script does look like that. Mark as complete. Okay, so we could delete the other stuff. Actually, no, we could keep it. Check the enemy's line of sight is clear. In this game, it's important to check the enemy's line of sight to Jaunt Lemons is clear. Otherwise, then the game could be triggered when there is actually a wall in the way. Since the player's character position could change at any moment, let's check this. I know the method immediately below on trigger exits. It only makes sense to check the line of sight when the player character is actually in range. Add the following statement. So far, so go by how can you actually check the line of sight? In Unity, it's possible to check whether there are colliders along the path of a line starting from a point called raycasting. In Unity, your ray needs to have an origin and a direction. The origin is just the POV game object's position, but working out the direction is slightly more complicated. Okay. So we don't need starts. Okay, so oops. Once if you enter the eyesight of the camera, I mean the gargoyle, it's true. If you leave it, it's false. So what happens when you actually enter it? Right? Yes, what happens when you actually enter it? So we need this variable. Let's see what this variable does. Vector 3 direction, so it's your position, player that position, minus transform that position. Okay, plus vector 3 up. What does that mean? The code creates a new vector 3 direction. From vector math, we know that a vector from A to B is B minus A. That means that the direction from the point of view object to Jaunt Lemons object is Jaunt Lemons minus matches point of view object. Okay. Oh, transform that position is the gargoyle's position. Yes, right? Am I correct on that? No. Yes, it is. Okay. This is the player's position, this is the gargoyle's position. Okay. Or the point of view object's position. Jaunt Lemon's position is on the ground between his feet. To make sure the observer can see Jaunt Lemon's center mass, you're pointing the direction up by adding vector 3 up. Vector 3.up is a shortcut for 0, 1, 0. To make sure the observer can see Jaunt Lemon's center mass, point the direction up by 1 unit. How do you know it's just 1? Okay. So we're making a new raycast. Add the final line code below the direction variable. So the direction is where we are minus where it is plus 1 up. Okay. And ray takes the position of the gargoyle to the player. Okay. New creates a new ray object. Some syntax. Now you can create a ray, you can perform a raycast. There's a lot of different raycast methods in Unity. All of them do things in common. They define a ray along on which raycasts happen, restricts sort of colliders they detect. The raycast method you'll be using returns a bool. It's true when it has something it hits, and false when there's nothing. Because it returns a bool, it's very convenient to put a raycast method inside an if statement. Okay. If physics.raycast to ray. So if it hits something, can raycast by not restricting colliders that can be detected. So we made it, but we're not restricting anything. You need to check whether it's a player or the player, where check whether this is the player character. But there's a problem. You get information from a method is with its return, and its returns only bool. However, luckily there's a very similar raycast method that has out parameter. Okay. Alright, so we're adding a variable right here. Raycast hit and out raycast hit. Boom. So that not only does it return a true or false, it also sets what we hit. Nice. And now we check if raycast hit dot collider, right? Collider dot transform equals to player dot transform. Oh, just player. Oh, player's already transformed. Okay, my bad. Players are already transformed. Nice. Game ending, game ending. Game ending. Add the game ending variable. Actually, let's put it above here. Nice. What do you mean it's done? Your script is nearly, oh, it's nearly finished. Oh, okay. Nearly fast. I thought, like, what? It's not done yet. So I have to do the fade, right? Yeah. Let's review your game ending script. Okay, so what we're doing now is we're referencing a script we already made, so we don't rewrite code. So that's what this is. This is gonna be calling that other script that we already made to make it fade in and out. So yeah, that's what we made. Correct way to end the level. So we want to open the other code, right? Yep, okay. So now we go back to our other script. This one, game ending. We're gonna add another variable, which is the caught background image canvas group. We're gonna make bool is player caught. Yes. And if player is caught, end the level. Where did they add that? An update. Oh, here. Else if. Or we could just do else. But okay, we'll do else if. Is player caught? Wait, why would we do that? Why would we do it like this? Why would we code it like this? They're calling the same thing. They're calling the same thing. Wait, let me see what they're doing. Where does this get set? Okay, now I know that. Okay, so we're gonna have different inputs. Okay. All right. Now that makes more sense. Because in the beginning it didn't make any sense because why would you do that? Okay, so now we do this, right? We added the canvas caught. We added the player caught variable. And now we added two different possibilities. If you win the game by exiting or if you lose the game by getting caught. Both go to endgame, but we want to change endgame to be dynamic. So it's going to take a dynamic canvas variable. So here we would do canvas group. Oops. We just do canvas group. We could call it, what do they call it? Image canvas group. Okay. Image canvas group. Or that. Image canvas group. And we change this to image canvas group. So now this is dynamic. So this will either be for the win or the loss screen. And now here we have to add a variable. So if we win, you'll be playing the exit. If you lose, you'll be playing the caught. Nice. So that makes the code more dynamic instead of having to manually do everything. Perfect. All right. Allow the player to restart the level. Do a restart. Ah, okay. So now they're automatically doing the... They're automatically doing the restarting or ending the game. All right, so here we're gonna add another variable called bool restart. And here, if you win the game, why would you restart it? So it'll be false. But if you lose the game, you don't want to exit, so it'll be true. And then instead of it saying quit here, it'll be if restart, then do something else, quit. I'm pretty sure I'm correct here. Okay, it's do restart. They changed. Okay, their variable is do restart. All right, I'll just follow it just because it's do restart. Just so we keep it consistent. All right, Unity C Manager. We need to import this stuff so we can reload the scene, I'm assuming. And put that on top over there. And then load scene 0. All right, so this is the first. Okay, so all the scenes have like a number. They will figure out later. They'll describe it, but for now, since it's the only scene that we have, it starts at 0. So, okay. You're done. So the last thing you need to do is actually make a way for the of setting M players caught. So far, you use public variables in the inspector, but this is not visible, so we're gonna have to do a getter and a setter. Yeah, it has to be set from the outside, so we have to do untrigger enter. So now we're okay, so now we're finished with the game ending, but we have to make sure that player caught is never set. It's never set at all. So we have to go back to observer, and here you do make another one under this caught player. MDF players, is that what they wanted? Oh, my bad. No. I'm going ahead. Not here. You go back in game ending. You add another variable that sets caught player equals to true. So if you caught player, and then here, it would be game ending dot caught player. Yeah. It'll be like that. They're going to show that this right now. Finish the game ending script. Yep. Game ending the caught player. Yep. So basically this. So let's look at this a little bit more. So if we enter the gargoyle's trigger, we're in range. If we exit it, we're out of range. If we're in range, then it activates a direction. It sends out a raycast. What I'm interested in is if we're in the range of the gargoyle, right? Then why do we need all of this? Because if we're already, if it saw us, we're inside the trigger. But this is doing, it's shooting a raycast. This already knows it's me. And if I'm in range, which means that I already am there, it saw me, then I do this stuff, so it hit to make sure I'm there. Not too sure why it does this. What do they say about this again? Because it seems redundant to me. Like, actually, it just seems redundant. Like, why would... Okay, let me quickly go over this again, because I think we're almost done. with this part. All right, so here we check the enemy's line of sight is clear. Oh. Oh, I see. Oh, okay, that makes more sense. It's so that like we could be in the range of the gargoyle, but what if there's a statue in front of us blocking sight, right? So then it won't actually see us. Okay, that makes sense. That makes more sense. Although I feel like it shouldn't be a line though. You could make a different. I know you can make different type of ray cast. You can make like a cone ray cast. You can make like a line. So I think this is just a line. So it seems like a cone would make more sense because like you're not gonna just look in a single line. You're gonna look at a cone, but we're doing a regular line for now, which is fine. All right, makes sense. Makes sense. Make a sense to do. All right, now we want to save the prefab, save everything, and we're trying to change the gargoyle's position. All right, so now we want to save. Make sure this is saved. Click the save button. Go back. Click save everything. Go back. Go to the gargoyle. Change its position to negative 15.2. Tab 0. Tab 0.8. Tab 0. 135. 0. Where'd it go? Where'd it go? Why is it over there? Oh, negative 15.2. My bad. Why is my negative not working? What? Interesting. Wonder why my numlock negative was not working. It's not working at all? Interesting. We'll have to deal with that later. Oh, I remember. I think I have it set to something else. Like if I do this. No, okay. Well, I'll investigate. I'll investigate through. Anyway, set the negative. Now let's see where it is. Perfect. Oh, I thought I wanted to be on the chair. I guess not. All right. Okay. Drag the Jaunt object in the hierarchy window. Drag the game ending field. All right. So now we gotta set all the variables. Let me move this over. So you go to the gargoyle and it has, we go to the point of view and it has player game ending. So we have to drag Jaunt Lemon. Perfect. And we have to drag the fader canvas. Exit image, or no, it has to be a new one, right? Click on exit fader image, duplicate it, rename it to caught image background, and then rename exit image to caught image, and then we want to replace the source. Instead of 1, now it's caught. Perfect. And now we drag the caught image background to the gargoyle. Alright. Caught image background. Wait, no. Finally, need to assign the caught background image canvas group on the game ending script. In the hierarchy, select the game ending objects. Drag the caught image background game object from the hierarchy window onto your caught background image canvas group. Oh, that's a script. Wait, what? Wait. Did I skip a step? Did I just skip a step? Right click the, okay, we duplicated it. Rename exit image to caught image. So we did that. Yeah. In the inspector window, you should only see the opponent still referencing one sprite. We changed that to caught. Finally, need to assign a reference to the caught background image canvas group on the game ending script. On the game ending script. On the game ending script. So this is the game ending script. Game ending. My... Oh, okay. I was so confused with the names. Okay, my bad. I was to drag this onto here. And then... okay, I'm trolling. And then the gargoyle had the game ending object. There we go. Cool. I was confused about the names. I was like, okay. Now you can, now your goggle complete. You can enter playtest mode. Cool. Let's see if it works. Always playtest. He doesn't see me. He saw me. If I click on him, I could see where his thing is. So if I do this, look. I can see how accurate it is. Hey. That's pretty accurate, I guess. Alright, so that works. Let's make it even, I guess. Drag it like this. He doesn't. See, it's not fully with the flashlight. I feel like you should attach this to like the flashlight's motion. I'm not sure you could do that because the gargoyle has no like body parts, but it's fine. Alright, that works. Now let's see if the other thing works. Let's see if winning the game works. I don't know which way that is. Is that this way? Nice. Wait, where's the end game? Is this way? How do you win this game? I think it's pretty long. Alright, here we go. This is the ending hallway. So when we get to the end of that door, it should say we won. And the game should end. Nice. But it doesn't quit because we're not actually in the game. Okay, cool. One more test. Cool. Perfect. It never starts. But yeah, so we finished this part in actually record-breaking time because it said it'd take 55 minutes, and we finished in 45. Because we're the best. All right, so next part will be dynamic observers, enemies, part 2. All right, so now we're starting the part 2 dynamic observers. Let's go set up the ghosties. All righty. The ghosts. So we have to bring in the ghost one, bring in for editing. Okay, so the usual stuff. Bring in the ghosty, go to the scene. Assets. Models. Characters. Ghosty. Double click, click on him. Make him a prefab. So we want to drag him into prefabs. Original. And open prefab editor. Perfect. Let's rotate him. Oh, see, this one has arms and stuff. So this one has animations, more complicated ones. So like I was saying before, like we could actually attach like an object to like his left hand, and then it'll be more accurate, like say if he has a flashlight or something. But anyway. We're good here. Let's click save. Completed. Animate the ghost. Same thing. Make the animator. Does he have more than one state? Ghost walk. Ghost shower. No. Alright, we should know how to do this by now. What do they call the ghost animator? Just ghost. Alright. So now we should have this memorized, or at least try to. So go to Assets, Animation, for Organization, Animators. Make a new one. Create Animation. Actually, no, not that. Delete that. Click the wrong one. Create Animation Controller, call it Ghost. Open it. Go to Animations. Drag in the ghost walk. Boom. We have that. Go back to the scene editor. Click on Ghosty. And then drag the ghost animator. Animation, animators. Ghost animator onto ghost. Boom. Perfect. Look at that. We're doing this fast now. Marcus complete. Add a collider. Add a capsule collider. Okay. Okay. Add a capsule collider. Now we gotta start bumping out this fast. We're learning. 0, 0.6, 0. .25. 1.2. Nice. Cool. Okay. It fits well. It does. Add a rigid body. Ooh, rigid body. We're gonna make this guy move. Add rigid body. Enable as kinematic. You can avoid movement by enabling all constraints for position and rotation, but it's easier approaches to set rigid body as kinematic. This only is because it is moving. Ghost will also need a rigid body because it's moving. You need to be careful with these settings. For this, a collision with Jaunt Lemon shouldn't cause any movement in the ghost. You should avoid movement. You could avoid movement by enabling all constraints for position and rotation, but its easier approach is to set rigid body to kinematic. Inspector rigid body component enable kinematic checkbox. A kinematic rigid body cannot be affected by external forces such as collisions, but it can still collide with other game objects. Okay. So we don't want to be able to push the ghost. All right. Make it is kinematic. Mark is complete. Make the ghost an observer. Oh, so we're gonna add the. Interesting. All right, so we want to save this guy. Save. It's good. Save. Now go back. Now we want to go to point of view. Point of view has the observer stuff on it, like the camera stuff. So we want to go to assets, prefabs, and make the point of view a prefab. Wait, that's not how I do it. That's how I do it. Assets prefab, select gargoyle prefab, open prefab. Ah, okay. It was correct. Sort of, kind of. So now in here, we drag it. Now point of view is a prefab. Click save. Go back. Go to the ghost. Open the ghost up. More cat is scratching the couch. Oh no. Anyway. Add the ghost point of view. Drag the point of view object into the ghost game object. Okay. Boom. Nice. A little bit big though. The ghost other than ghost and looks down, while the ghost needs to look straight forward. So we have to change the stuff. 0, 0.7, 0.4. 0, 0.7, 0.4, 7.5. 0, 0, 0. Alright, that makes sense. I'll make it smaller, but makes sense. Cool. Set up a nav mesh agent component. You ready to set the ghost so it can move around the game environment? You're going to use two components. A nav mesh agent, and the nav mesh we already baked. Yes, we already have a nav mesh. The script will tell the nav mesh agent where the ghost should go. A script which tells the nav mesh agent where to go. Okay. So we want to add a nav mesh agent to the ghost. Add. Actually, let's collapse these so we could see. Add a nav mesh agent. So it looks like that. Want it to be, this is a little big, want it to be 0.75. 1.5. What was it? Radius 0.25. Speed 1.5. Stopping distance 0.2. Should we lower the height as well? No? I feel like we could change the height, but I guess it doesn't matter. Interesting. Because if we change the height, it looks normal, right? Alright, well, I want to make it look better. Hey, 1.2 is literally perfect. 1.25. Perfect. Okay, I'll do that. I am engineer. Save your changes. I have to write a script. Okay. So save. Go back. Now I'm gonna add a new script. Scripts. Create C# has to be called patrolling. Reload all. Yes. Waypoint patrol. Perfect. Drag it onto the ghost. Okay, make sure we drag it onto the ghost first. Here's the ghosty. Waypoint. Boom. Minimize this. Alright. Ready to code. So destination of the nav mesh agent. So we have this. Remove the comments. Fine, we'll move those. Unity Engine AI. Okay, that's new. New namespace. Do that. Remove this. We don't need those anymore. We learned. What does it be? Public nav mesh agent. What was it called? Nav mesh agent. Okay. Does it for you. Proper syntax. Alright. Next, you want to set waypoints that the ghost should patrol. A nav mesh agent destination is a vector 3, a position in the world space. But if you made the waypoints vector 3s, you'll have to manually set all the positions and hope that the numbers you use are accurate. Instead, it makes sense to have a collection of empty game objects. Okay. Make an array. Alright. Alright, so we're making an array. Holds a group of objects, okay. Public array. No, not array list. Wait, what was it? Vector 3s. Vector 3. Oh no, it transforms. Okay, my bad. Transform waypoints. Next line in your start, set the nav mesh agent to the destination of the first location. So boom. So now to start, the nav mesh agent will be set to go to the starting position, which is waypoint 0, which we haven't set yet. How do arrays work? I know how arrays work. They start at 0. Add additional destinations. Okay. This will be the current. This is going to keep track of the current position we are at. Let's move to the update method. Now, update method, you need to perform a check if you want to know if the navigation has arrived at the destination. It's an easy way to check this, see whether the main distance destination is less than stopping distance. Okay. Okay. This is all new to me. So if the nav mesh in the remaining distance is less than the stopping distance, which means that we're not to our destination yet. Actually, no, it's... we need to know... And each way to check is see whether the remaining distance to the destination is less than the stopping distance. Okay, there's no... Okay, so if the remaining distance is less than how far you are, shouldn't it be equal to each other? Like if the remaining is 0 and stopping is 0? Can this be... What? In the update method, you need to perform a check. You want to know if the nav mesh agent has arrived at its destination. An easy way to check this is to see whether the remaining distance to the destination, so the remaining distance to the destination is less than the stopping distance. You sat in the inspector window earlier. Oh, this was 0.2 and this will be 0. Okay. Okay, that makes sense. So the stopping distance is... It didn't really make sense. Why you couldn't just make it equal? You could make it equal 0, but it's this 0.2. So if this was 0, then it would be 0. That's what I was saying. Okay. Makes sense. Now that you need to update the current index, so you'll set the nav mesh agent's destination. You do this by the new operator called remainder operator, which represents the percentage character, yeah. And the following code. So current waypoint index is current waypoint plus 1 divided by the length of waypoints to find the remainder. Okay. The remainder operator takes whatever is left and divides it by whatever is to its right. For example, 3 divided by 4 will return 3. It's the remainder. Because 4 goes into 3 0 times, 3 is left over, 5 goes into 1 time, yes. Your code is saying add 1 to the current index, so from 0 to 1. But if that's the if that increment puts the index equal to the number of elements in the waypoints array, then instead of set it to 0. It'd be set to 0 because the remainder. Okay. Oh, so basically it goes 0 1 2 3 4 0 1 2 3 4 0 1 2 3 4. Because this is 0 plus 1, 1 divided by 4 is 1. If it's 1 plus 1 is 2 divided by 4 is 2. If it's 2 plus 1 equals 3, 3 divided by 4 equals 3. And if it's 3 plus 1 equals 4, divided by 4 equals 0. And then it'll be 5. It keeps you going in a loop, basically. Okay. And we set the destination. So that gets the index. So if there's 4 waypoints, it'll be 0 1 2 3 0 1 2 3 0 1 2 3 because of this remainder. And then we set the destination to the index of this. Cool. Yep. Now your script should look like this. It does. Assign the nav mesh agent reference to the ghost prefab. Alrighty. Save. Now we take the nav mesh and we drag it into the nav mesh section so it knows what it's looking at. Then we're going to have to set the waypoints. Save the ghost prefab, return to the scene. Save. Oh. Okay, I made a mistake. I was editing the single object. Okay, don't make that mistake. I left... Okay, let's remove this. Uh-oh. So I was editing this prefab by itself. I wasn't in the editor. So I didn't actually add it. So now I gotta add it back. Add this. Boom. Now it's okay. Now we save. Now it updates the entire prefab forever. If I want to add more of them. Okay. Make sure you don't make that mistake. Don't edit it here. Edit it in the editor. So it saves for all prefabs. Not just this single one. Okay, good. Close one. Now go to export. Let's check the Ghost Observer script from the references it needs. In the hierarchy, expand the Ghost game object, select point of view. Drag John Lemon. Okay. So we go to point of view. We have game ending and John Lemon already. We already have that. I mean the ghost. Point of view. We have to add the same ones. Game ending. I mean the game ending object. And which has that script game ending. And we need to add John Lemon to the point of view. Boom. Theoretically speaking, we could make this. We could actually set this in the like if we went here, we could just set it in the prefab editor so it automatically does it. But let's see, we're learning, but it's fine. Do it manually. That's how they're telling us to do it. Perfect. Now we have to place ghosts onto the scene, but we didn't make the array yet. Okay, that's next. Okay. So we want to make 4 copies of the ghost. Okay. Let's minimize all this stuff. The ghost is set up. Go to assets. Prefabs. Does the ghost have everything correct? Let me see. No, see, it won't have this set. See? It won't have that set, so I want to delete this one. We could just make copies of... We should probably make this... We should have probably made this a prefab, right? Okay, let's just make us duplicate. Okay, so in reality, we wanted to make this point of view in the prefab editor. We wanted to add the player and the game ending because they're going to say the same. But it didn't seem to do that in the tutorial. So instead of just dragging this ghost, which doesn't have point of view set, we could just duplicate this object. Duplicate. But now it'll have it because we duplicated directly. Okay, perfect. Let's move all the ghosts together. Oops. Want it right here. Perfect. All right. First ghost should be negative 5.30, negative 3.1. Let me move my thing to the side so I could accurately see. Negative 5.30. Negative 3.1. That's the first ghost. Then ghost 1 will be 1.504. 1.504. And then next one will be 3.206.5. 3.206.5. And then the last ghost will be 7.4. 0, negative 3. Perfect. Should be good. Now we have to create waypoints. Create a new empty. Are we going to have to do them for every single one? Ooh. Alright, we're going to make duplicates of them. And now we have to make 4 different waypoints. Okay. Alright, a little bit tedious, but you know, it is what it is. Alright, create empty waypoint. Duplicate the waypoint object 9 times to create 10 waypoints in total. Yikes. Oh, we're making 9 different ones. Oh, okay. Alright, I'm gonna drag this over here so we don't make any mistakes. So we're gonna, let me save the scene. Alright, create empty. Rename it to waypoint. Duplicate it 9 times to create 10 waypoints. 1, 2, 3, 4, 5, 6, 7, 8, 9. In the hierarchy, select the ghost game object. Select the ghost. Go to waypoints. Add drag waypoint. Wait. Waypoint. Scroll down till the waypoint patrol component is visible. Yes. Drag the waypoint object from the hierarchy onto the name of the waypoint field to add it to the array. Should be 2, right? Yeah, like that. Now it's 2. 1 and 2. So waypoint 1 to negative 5.3 tab 0 tab 6.7 and set this one to negative 5.50 negative 4.5. So these two are completed. Yeah, first one has 2 waypoints. Yes. Second ghost 1. How many will he have? He'll have 2 waypoints also. Set this to 2 and bring in this one and this one. This one will be 1.70, 7.7, 1.20. I mean 1.2. Tab 0, tab 7.7. This one, waypoint 3, will have 0.9, 0, negative 3.5. Cool. Now go to ghost 2, 4, 5, 6, and 7. Oh, this is 4. Be 4, 5, 6. This one's a smart one. 4, 3.2, 5.6. 3.2, 0, 5.6. Next one, number 5 will be 3.2. 3.2, 0, 12.3. 6 will be 6.5, 12.3. 6.5, 0, 6.3. I mean 12.3, my bad. 12.3. And number 7 will be 6.5. Basically making a square. They say all squares are rectangles, but not all rectangles are squares. True. 5.6. All right, now Ghost 3. We'll have only 2, 8, and 9. 8 will be 3.2, negative 0.5. 3.2, 0, negative. Oops. Negative 5 on the dot. 1.9 will be 7.4. 0, negative 12. Cool. Now our ghosties are finished. Nice. Now we place more gargoyles. All right. Now we're gonna add more gargoyles. Let's see. You ready to place your first gargoyle? Second one should go on the bottom long corridor. So John Lennon can go too far down. Okay. So take our gargoyle and put it here. Take our gargoyle, duplicate it. Gargoyle 1. Duplicate. Gargoyle 2. Gargoyle 1 will be negative 2.6. 0. Negative 8.5. And rotation will be 30. Nice. And then gargoyle 2 will be negative 4.8. 0, 10.6. Cool. Completed step. Make sure we save so nothing crashes. We just did a lot of things. Hopefully everything works smoothly when we test it. It's good to like test things bit by bit, not just do everything. Clean up the hierarchy. There's one final thing you do before you completely finish with the enemies and the waypoints. Titty them up. That's looking globally clustered. In the hierarchy window, create a game empty object. Rename it to enemies. Set the enemies to 0, act as a parent to all ghosts. Okay. So basically, okay, now this is the organization part. So you create empty, make it 0, 0, 0, rename to enemies. So it just holds all your enemies in an organized space, and then you're gonna click on gargoyle to ghost. Click on all of them with control. Drag them into the enemies. Now we gotta hide it. And same thing with waypoints. Create 0, 0, 0. Rename to waypoints. Gonna hold the way. You can actually click the first one and click shift and gets all of them. Boom. Now that's organized. Everything looking pretty organized. Nice suit. Yep. So complete. Boom. Nice. Let's see if it works. Moment of truth. Let's go into scene first. Alright, that guy's still working fine. How's this guy walking? This guy's walking pretty good. Okay. Click on him. Click on his point of view. There's Capsule Collider. Okay, pretty good. What about this guy? All these guys? Oh, this is the guy with the box. cool. It looks. Let's see if they. There's one statue. Where's the other statue? Here. All right, let's try to play it out. See what happens. If he sees me, do I lose? Nice, it works. Really good, really good. Don't mind if I do. There's a ghost there. There's a statue right there. Ah! No, he saw me, man. This game's hard. Alright, it works. Alright, so we finished that part of the tutorial. So now, next part is audio. Cool. Only took 34 minutes, and they said it would take a lot more. Cool, cool, cool. Alright, so now let's do the section right before the last one. We only have 2 more. Audio, then the build. Boom, let's do audio. Start. Should be pretty quick, 30 minutes. 2 times kind of sounds. Non-diegetic sounds and diegetic sounds. From a source, which have no identifiable source. So these are like sort of like global, and these come from like your left ear, your right ear, depending on what side it is. Let's start by adding the non one. Okay. A primer on audio in Unity. Audio clips are assets such as MP3s that contain all data. Audio sources are components in which act as the origin of the source. Audio listeners are a single component in a scene that works like the ears. The audio, where the audio is coming from, who's listening. Okay. Different types of audio work together. Spatial sounds, particular audio source determines whether it sounds like it's coming from a particular point in the game, or does it matter the distance? Okay, yeah. So this is like the left ear, right ear. If you're starting with a non-diegetic audio, since the sound doesn't have an origin, its spatial blend is set to 2D. When its spatial blend set is purely 2D, the distance between the audio source and the audio listen does not affect the volume. Okay. It would be like a cave. It's like ambience. Yeah, ambient. Yeah. Create game object ambient. Assets audio. Okay. So let's minimize all this stuff. Make a new empty. Well, you make a lot of empty game objects to hold a lot of things, apparently. Ambience. Inside ambience, add component, audio listener. Audio source. Audio source. Cool. Oh, they named it ambient. Okay, fine. Okay. Now we want to drag SFX house ambience. Set it to 2D so and play on awake. However, it'll stop by default, so we have to loop it. 0.5. Volume will be 0.5. Play on awake, loop. Audio clip will be SFX house ambience. And it's already been set to 2D spatial blend. Where is that set? Oh, here, 2D. Oh, you can make it like half. Okay, that's interesting. Okay, it's fully 2D. 0. Good. Duplicate your audio source. Escape caught. So volume to 1. All right. So here we duplicate this and rename this as escape. Spell it right. Escape. And duplicate. This one will be caught. And here we go to escape. We change this to the SFX win. Don't play on wake, don't loop it, and make it volume 1. Caught, same thing. This will be SFX game over. Don't want it to loop or play on awake, and we want it to be 1. Cool, pretty simple. Yep. Tied up your audio sources. Rename it to audio. Oh, they want to just organize our audio sources. Alright, so make a new one, create empty object, rename, call it audio. Make sure this is 000, don't forget that on all of them. Just so it's all in the correct place. Guess it's just good practice. Can I highlight? Ambient. All right, now we take all these, put in audio. Cool. Now we want to go to our game ending variable. We're probably gonna have to change our script here now to play the sounds. Yep. Exit caught audio. So go back to your script for the game ending. Add public game audio. Is it just audio? Audio source. Shouldn't it auto do it? Audio source there. Audio source game ending. No, caught audio, exit audio. Okay. Caught audio. Take this. Exits audio. Nice. Now we got to set it. Audio has played. Okay. So it doesn't like loop, I guess. All right, complete. Now set our new variables. End level, audio source, exit. Okay. So now in the end game method, we're gonna do audio source. So that'll be the variable we have to put in, and then now they don't match the variable, so we have to make sure we add. Oops, not that. Make sure this is the game winning, so exit audio, and this will be caught audio. Perfecto. Make audio play. If audio has played, make it only play only once. If audio hasn't played, audio source stop play. Oh, okay, there we go. Now we play the audio. Oh, pretty good. And then we got that also said, and that has played equals to true. Just in case, right? Yep. Perfect. Now we have to save the script and make sure we add that stuff to game ending. Cool. So now we saved it. Now game ending's gonna have 2 new sections, and it'll be escape. And whoops. Escape. Caught. Nice. Add footsteps. Or John Lemon object. We're gonna add Okay. Okay. So now we go to John Lennon. John Lemon. Add audio source. And this will be footsteps looping. Make sure it's not playing on wait, but it is looping. And how loud do we want it to be? Just the same. Okay, whatever. Audio source, looping. Disable play on awake, but we want it to loop. Okay, we did that. Now the player movement script. So we're going to do the same thing to the player movement script. We're going to add an audio source, all that stuff. Maybe we could do it ourselves. So let's try to do it ourselves. So we're going to have public audio source, let's say footsteps. Right, let's do that. And then when the walking animation is true. So when walking animation is true, we'll do footsteps dot play. And then I'm assuming that when we're not moving, it'll be footsteps dot stop. Nice. Let's see if I'm correct. Okay, they just said audio source. Oh, they did it differently. Why don't we make it public, though? I made it public. I guess they're just trying to get us used to... Okay, so what I did was correct. Okay, they're doing it differently. Okay, so what I think mine would work, but they want to do it differently. So they don't want to make it public. Okay, that's fine. They want to do audio source M. Let's just do audio source. And then they want to do in start m.audio source. What? I should have actually made these M's to follow convention. Let me do that right now real quick. Just so it looks better. That's just so I fixed that one bug that I did like 2 hours ago. I gotta change all of it. Oh boy. Good. All right, so now m_audio source equals get component audio source. And now this will be this. Instead of footsteps, it'll be audio source. So play when I'm walking and don't play when I'm not walking. Let's go. Sort of fast forwarding here. Yeah, see, it's walking. Oh, we have to add if it's not already playing. Oh, okay, so I missed a step. I have to make sure is okay. So it doesn't keep looping. Okay. There you go. Now we're good. Mark is completed. Move the audio listener to John Lennon. Lemon. Move the audio listener to John Lemon. The final piece of audio is game spooky sounds the ghosts will make as they pass. This not only develops the atmosphere, it also helps the player identify close to danger. One challenge is the ghosts won't get louder as they get closer to the John Lemon. They'll get louder as they get closer to the camera. This is because audio listener is on the main camera by default. So remove it from, okay. Remove audio listener from the camera. Okay. Make sure we save. Cool. What? Omniversion sounds sensitive object. Why do these bugs keep this weird bugs keep happening with? That have nothing to do with our game. Anyway, just clear them. Alright, so we're gonna save. Go to main camera, remove the audio listener. Go to John Lemon, add an audio listener. Okay. Yes. Update John Lemon prefab. New components have been added the new components that you have added have a plus over their icon to show that they have been added to the prefab instance, but not the actual prefab. In the hierarchy, you can fix it by applying these changes to the John Lemon prefab. In the hierarchy, select John Lemon game object, find the overrides drop down. The override drop down shows you all the ways that John Lemon instances are different. The pluses? Where are these pluses? Oh, these pluses. Overrides. Apply all. Ah. Nice. So now the prefab has it. Okay, that's a good shortcut. Add sounds to the ghosties. It's like one of the ghost objects. It's like one of the ghosts. I'll use the arrows shortcut next to it to open the prefab for editing. Okay. So now we want to go to the ghost enemies. Go to ghost, open the prefab. We should probably update that here too. That's fine. So we open the ghost, and in the ghost we're gonna add audio source, and then we're gonna have loop, play on awake, spatial blend will be 1, volume 0.4, so it's not too loud. Should be playing awake also, yeah. Adjust the 3D sound settings feature. Let's adjust a couple of advanced features to really make your sounds really spooky. In the audio source component, expand the 3D section. Okay. Oh, here we go. Okay, this is just like the distance. Change the max distance property to 10. Setting the max distance will mean that when it goes to 10 meters away from the player, you will hear them, but very quietly. Okay. So yeah, 500 meters really far. One final thing to fix: can correct the direction of the ghost sound. You put your audio listener component on John Lemon, but there's a small problem. When John Lemon turns, the audio listener turns with him. This means that the John Lemon's is facing towards the screen, the player's virtual eyes, camera, but the player's virtual ears, audio listener will be facing different directions. Okay. Because this, the ghosts will sound like they're like on the opposite side. Let's use a combination of two properties to make the ghost sound seem directionless, but it should still get louder. Okay, so it's basically saying that the SFX ghost move. Oh, we never set the audio. Oopsies. My bad. SFX ghost move. Is set to mono instead of stereo, which means that the sound is identical through the left and right channels. If you want to see the import settings, okay. In audio source of the ghost prefab, find the 3D sound settings. The spread property controls the range and degrees that the sound seems like it's coming from. Set the spread to 180. This means that half the sound will come from each channel. And since these channels are the same, the audio will seem directionless. Is that what we want, though? So there's a custom roll off. Forgot to do that. Getting a little bit sloppy. Spread to 180. Don't we want them to hear from our ears, though? There's a small part of elements. The audio listener turns with him. This means that the challenge is facing towards the screen. The player's virtual eyes, camera, and the player's virtual ears will be facing the different direction. Because of this, the ghost will sound like they're on the opposite side. But don't we want them to have directions? Why do we want the audio to be directionless? Don't we want to hear from the right ear or from the left ear? Okay. I'm trying to understand. The audio source is for the ghost prefab. Find the 3D sound setting. The spread property controls the range and degrees that a sound seems like it's coming from. If you set it to 180, it means half the sound's coming from each channel. Okay. So there's no way we can make it sound like... Alright. Let's just complete it. So now we're finished with this part. We're up to the last one. Okay, let's see how if the game actually works. Let me save this. Go back. Make sure all the ghosts have the sound. All the ghosts still have the point of view correctly. Yes, sir. Let's see. Jaunt Lemon has the audio footsteps. Let's mute my music and play. That's a pretty good sound. Sounds pretty good. Really nice, actually. I want to see what happens if I go to... Oh, let's play the caught sound. It works. Cool. I want to see what happens if I go to enemies. Go to this ghost. This is the first ghost. What if I change it to... louder? Lower? Okay, so what if I made it... this 3D sound. What if I made it... Oh, it shows how far away you are. That's so cool. What if I did spread 0? And now I hear it from my right ear. Which is what I wanted. Oh, I see. It doesn't work. Yeah, okay. Yeah, okay. So it doesn't work. So which means like you have to have the spread 180. I want to find out how to make a sound so it comes out of your left, because they said that if it's on your character, the audio listener, then it like rotates, but you don't rotate. So I wonder how you make it rotate. Anyway, sounds pretty good. All right, we're pretty much done with the game. Now we're doing the last part. Oh, we had an error. Where's this error coming from? Unity editor graphs that edge that wake up. That's not a part of our code. That's something that's happening with something that has nothing to do, and it's not breaking the game, so we're fine. But yeah, let's get into the last part, which is build and distribute. All right, so now we're on the last official part of our tutorial. We just finished audio. If you were getting some weird errors that you have no clue what's happening in your console with audio or something, just restart your Unity and it went away for me. Just so. But anyway, now we're going to do the last part, which is building our game. This is how you get your game onto Steam and stuff. All right, adjust basic player settings. Edit project settings. All right, so let me just save everything. Edit project settings. Ooh. All right, we want to go to player. Ooh, company name. Maxkey Productions. Product name. We'll call it... Okay, that's fine. Version 1.0. Company name is used to create the folders where the company name is used to create the folders where your files created for the build game will be stored. You can use it if you want, but that's required. That isn't required for the build process. Okay, that's fine. All right, so I'll call it Maxkey Productions. Let's call it Maxkey Games. The product name is the name of your game. So let's change it to John Lemon's Haunted Jaunt. Let's call it Maxkey's John Lemon's Haunted Jaunt. Okay. The downward arrow button at the top section here means that all settings in this section are for PC, Mac, and Linux standalone platforms. If you're just for other platforms, then when installing Unity, you'll see multiple toolbar buttons. Okay, this is Android, iOS, Universal Windows platform settings. This is PC, Mac, Linux standalone settings. Alright. Alright, you'll highlight up a couple of here. Just click on resolution presentation. Click on resolution presentation. PC, Mac, Linux. Settings for Universal, iOS. Then you have to change all of this for every type of game that you want to build it for. Okay, so resolution. Full screen. Mac restaurant run in background? No. Run background determines whether the game continues to run in the background. No, well, we could, but... Alright. Display resolution dialog. This allows you to show a window when the user launches the game. Oh, okay. Display resolution on dialog, resizable window. Visible in background. What was that option? Standalone player option. Display resolution dialog. Display resolution dialog? We don't have that anymore. It's probably allow full screen switch. Full screen mode. It doesn't say. Okay, it's fine. Settings might change. It might always allow full screen switch. In the standalone player options subsection, make sure that the display resolution dialog is set to enable. Standalone player options subsection. Standalone player. Oh yeah, this is a subsection. And it said display resolution dialog. We don't have that. Okay. Okay. In splash images, you can change the images shown on the top of the dialog. In application config dialog banner. In the splash images section. Splash images. Make icons. Splash images. Do they have one? Application config dialog banner. Oh, that's what it's called. We don't... Oh, we don't have one? Man. You can make it anything, though. We can make it like 1 or something. That's fine. We don't need one right now. Build your game. Yeah, you can build it for different thingies. File, build settings. I kind of want to add something though. We could just add the 1. Yay! It'll look better. And then for the icon, we could add a ghosty. Other settings? I'm not gonna touch any of these. How it's compiled and stuff, yeah. Icon. Where do I set the icon? It says override for PC. Does it mention anything about icon? Doesn't say anything about icon. Okay. So this is the icon of the actual game. Should we just put the ghost? I mean, should we put... Oh, wait, we don't really have a picture of anything, though. Okay, whatever. It's fine. That being said, we're good here. Now we go to File. Let's just click Save. File, Build Settings. Yes, File, Build Settings. PC, Mac, Linux. Okay. So we build stuff. The scenes in build section are top. List all the scenes that you'll be used, including your game. If your main scene is open, click Add Open Scenes to add it to the list. Alternatively, you could drag and drop your scenes from the project window to the scenes. Okay. So, add open scenes. Okay, we added the main scene as the first scene, so it's 0. Is that it? Player settings. What is that? Oh, nice. Oh, cool. Okay. To install more platforms, install Unity Hub, and then install different. Okay. In the bottom right, there are settings related to the current selected platform. These settings are mostly for debugging and special builds, so you can ignore them for now. For now, let's run the build file and install any other. Blah blah blah. Unity will open a file explorer and ask you where to save your folder. Okay. Build. Let's save it to Unity Games. Should we just set it to the? I'll save it to the beginner folder. Okay. Create a new folder called Build. Oh. Oopsies. Cancel. It's gonna populate my folder with random junk. Did I just exit Unity by accident? Oops. Oh, I just exited Unity by accident. Oopsies. Little bit slow. Alright. File, build settings, build. So in here, make a folder called new build. Select build. Now it's building. Okay, cool. And then mark as complete. What does Unity produce? Presses the packages. Mark as completed. Summary. You finished your project. Woo! We finished the entire course. Let's go. Nice. Together we finished it. Now we're better developers. All right. Still building. Let's exit this out. And let's see what happens. Then we just run it, and yeah. The faster your computer, the faster this will take. My computer is pretty fast. It's still taking quite a bit, though. It is a nice looking game, though. True. All right. $5 hours. It's gonna be like a 5-hour. It's kind of lagging my camera too, a little bit. Taking a lot of power to do this. Come on, Unity. Imagine a big game. How long it'll take to compile. Perfect. Boom. So now in your 3D, in your build folder, boom. there's your game. So let's close all this. Close everything out. Now we're in the folder. We double click Jaunt Lemons. See what happens. Oh, full screen, made with Unity. Oh, let's turn off my music. See if the game works correctly. Nice. Go, 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 go. Look at that. We are doing a playthrough of the game we made together. Beautiful. Actually, it's really cool, actually. We did this ourselves. Really cool. Speed run, speed run. Give me a timer. It's a speed run. We made it! And that's it. Perfect. Really cool. Well, I hope you guys enjoyed learning this process together. We made a game. So I'm going to continue to learn more stuff, then start making my own custom project, custom games, and teaching you guys stuff as well. Doing stuff together. And yeah, hopefully this YouTube channel will be more about games. I'll post my streams. I want to make like games with my stream on Twitch. I want to make my own personal projects, personal tutorials. So we'll see what happens. But yeah, hope you guys learned something. Thank you guys so much for watching. Comment, like, subscribe. And I'll see you guys in the next one.